Right, I think I'm here. Sorry guys, I'm just a bit late. Trying to sort stuff out. I was just chatting to some people on email, so I was a bit distracted from getting set up. So hopefully things are working alright. Since the last time I did a stream, I've updated my computer and some stuff has changed. So I'm just making sure that everything's working. Had a few little glitches when I was trying to get stuff going in, but it seems alright. Yeah, we're getting there. So, who do we have here so far? Wilhelm, Adam, Andre, Thomas, Sheldon, and Chris. Alright, cool. Hey Ian, he's here too. Yeah, I'll think about it. This little box I made for the tester. My 3D print didn't come out very well, but it's good enough. It's a box. It's yeah, the bottom's a bit crap. You can see the surface there, but that's just the bed face, you know. But yeah, it's not great print settings. This is using PETG, and I don't know if the settings quite right, but it's good enough for one-off thing which I'm going to use. But yeah, no, it's all right. So now I've got the switch on there, so I can turn it on and off with the switch. Still got to do the firmware update on that yet. Still got the original firmware on it. One day I'll do it. How do you pronounce that? Ayob? Is that right? I don't know. Dutch Linux. Sound a bit low. Well, it is a little bit low actually. Suppose I can turn up a little bit. Here we go. Let's crank this up some more. Here we go. That should be 3 dB more at least. Yeah, like I said, I did an update on my computer and things are different and changed a bit. And it's omnidirectional and it's facing towards me, so yeah, it should be. I'm using the right mic, aren't I? Apparently I am. So that's 3 dB more, so it should be close now. It's getting close to redlining, so that's should be alright. I suppose it depends how excited I get. Yeah, okay. So I've got a few things to work on today. Camera feels like it should be further to there. I moved it. Yeah, maybe. Yeah. There you go. Just not sure about this bloody lighting in. So I'm just. It tends to be a bit glary if I get these blinds set wrong. It's probably slightly better there, isn't it? More artificial light than natural light. Anyway, so I'm doing 1080p. We'll see how it goes as far as stream quality goes. It may or may not play up, but we'll find out. I've only dropped 66 frames so far, so that's right. That's before I dropped it down from 4,000K to 3,500K, which is probably fine anyway. So we should be good, I think. Hopefully. So let's see, what should we play with today? We got a few things. No, it's just playing back video. I need to turn that off. Don't need to wash myself. Just trying to readjust things here so I can see what's going on better. Right. Here's one thing that you can see. I want to do this. This has been sitting here for a couple of months now. I need to do this thing. So I need to refurb this thing. Get that thing finished. And there's also another gadget just on the right hand side there which you should be able to see. That's a Fluke device which I'm gonna also want to do today if I can. I'll do a couple of videos, one on each. A full wave, how's it going? Yeah, so those are two little repair and refurb jobs I want to do today. I don't even know if this Heathkit device even works. I haven't powered up at all, not been used at all, so that could be interesting. Maybe some faults with that. Don't know. Might work fine. But the Fluke thing does work, but I want to refurbish it because it's old. It needs a bit of love, I suppose. So I was actually trying to get my tablet here to talk to my computer. That's one of the reasons I was delayed. Is that I was trying to get my tablet, which I have sitting just here, plugged in, trying to get it to talk to the computer so I can transfer across the circuit diagrams of the things I want to work on. You know, put the manuals on the tablet, which is why I've got the tablet in the first place. So I can sit on the desk next to the work area and refer to diagrams on it. So I can have it on screen for you guys so you can see it, and I can have it over there for me to see it. It won't communicate with the computer. It used to work, but then I haven't done this since I updated the computer. So I'm guessing now there's some kind of software incompatibility. Yeah, so it's called Android File Transfer. Is a program. Which version is this? I might have to go and have a quick look so I can find another version. 1.012. Let me quickly go and see if I can find a new version because I kind of want to get this over there so I can work on it a bit easier. Unfortunately, the software doesn't have a thing to check for all the updates and stuff like that. Let's have a look. Maybe there's a newer version. Yeah, that looks like it might be quite old. Maybe this needs reinstalling. Maybe I'll fix it. Maybe it's a driver problem. Let's quickly do this because I kind of want to solve this problem. Yeah, so let's replace the one that's already on here. Let's just do that. Installed. Right. Hey Zine. Zine, I haven't seen you for ages. Aren't you the one which won one of those things I gave away? Didn't I give you, what was it? Was it a pocket? Was that right? Can't remember now. Yeah. That was it. Well, my computer's giving these security pop-ups now. No, it still doesn't work. So, there goes that. That's not an option then. I don't know. If anyone knows how to get a file transfer app to work between a Mac and a Android tablet, multimedia, that's what it was it? Yeah, okay. So I might have to do that with the tablet today. Hey Johnny, how's it going? Yeah. Anyway, so yeah, we've got a couple of things to work on. Also got some other stuff which, well, there's another device which I could work on, but you guys don't know about it yet. It appears in tomorrow's mailbag for the first time. So if I do it now, it's a bit of a spoiler. And it's likely to be a lot of work. So I don't think it's really going to be something we can start and finish in a live stream. Recovering from man flu. Oh dear. Yeah, so anyway, wasn't there something else I had going? What was that? I had another plugin, didn't I, which was working with OBS. I wonder if that's been broken now. Automatic scene switcher, which is something Ian turned me on to. Maybe it still works, maybe it doesn't. I don't know. I guess we'll find out. Stops me from trying to leave this thing in the wrong place and be off camera and you guys can't see what the hell I'm doing. I don't even know if that works. So I've updated OBS and my system since then, so hey Fred. Yeah, anyway, it's let's see, what was I going to do? There's actually something else I wanted to show you guys too. There's a multimeter which I was actually mentioning to Johnny Fix yesterday from what used to be a business called Dick Smith over here. You probably heard of them. Dave, EV Log Dave's probably mentioned them more than once. They've basically gone. This used to be like electronics retailers, a bit like OS, but much smaller. Anyway, they're gone. I think the name's been picked up by somebody else now. It's being used for general consumer electronics. Anyways, a multimeter which I bought from them like 20 years ago, and I've had it in my car for years and years. I've got a different multimeter in the car now. I've got a Fluke in there now. I always keep a multimeter in every vehicle because you never know when you're going to need one. Anyway, this one used to be in my car for years, and I believe it's still on its original batteries. I don't remember ever changing them, and it still works. I think it's about 17 years or something like that I've had it. It's amazing. So I thought I might pull that thing apart and have a look inside it and see if the batteries are turned to mush or it's working on potato power. I don't know. Budget scope for beginners. Depends on what kind of stuff you want to do. If you want to do any kind of digital or serial communication stuff, then you probably don't want to get any of the really budget ones because they don't really deal with that. The name that always comes to mind, hey Dave, is the Siglent stuff like the 1102XE or 1104XE, whatever it is. They're really good scopes, good bang for the buck, lots of features. Slightly more expensive. They're not like the very bottom end. They're a little bit up from that. So you pay a bit more, but then you got serial decoding and stuff like that built into them. Yeah, so yeah, it's kind of where I'll be looking. I keep trying to get Rigel to send me stuff, but they haven't replied yet because I've never used a Rigel. So yeah, I keep trying Rigel and I keep ignoring me. I've also got some other brands like I think Mixig. Mixig do like a little portable one. I don't know what it's priced like though. I know that the Paul over the Learn Electronics channel, he has Mixig stuff. He demonstrates that quite often. I again have never used it. I've tried to deal with them and they haven't really responded. I don't know. They've replied in comments saying, "Oh, we'll get hold of you," and then they never actually do. So, whatever. It's their loss. Anyway, yeah, for them it's advertising. It's free exposure for years and years because there's a video and people search for them. Anyway. Yeah, so, right. There was something else I was going to talk about. What was that? No, I'm trying to think what it was. Can't think. Oh, well, the bunch of emails turned up. So it might be important. Probably just YouTube turning on live. Yes, it is. It's fine. Okay. Yeah, there was something I was going to do. Now I'm looking around aimlessly, just trying to figure out what it is. I don't know. We should probably just go to the bench and start doing something. Maybe it'll come to me. So, you're triple colour now. Oh yeah, look. Yeah, so you are. You got 3 colours now. Well, actually, you're 4 colours because you got white for the text. Then you got the red and the green for the sponsors. Notice, the YouTube sponsorship thing. and obviously blue as the moderator. So it's 4 colours really. Yeah, anyway. You leveled up, Johnny. You leveled up. I should sound did last time. Hold on. I don't have any products featured on the live stream. I should have something. I think this one might be appropriate. Maybe. Let's find it. That's awful. This looks horrible. Okay, maybe not that one. Hold on. Come on, find it. It's all look awful on screen. This is incredible. That looks terrible as well. Hold on. So guys, just so I want to get sorted out. Here we go. This one do. Yeah, come on. Right. Okay. Let's go and jump on the bench and we'll do something over there. Let's get some lights on. I'll be able to see what I'm doing. Which view do we want? Do we want this one or do we want this one? It's weird. It's not deselecting properly. Since I found a bug in OBS, I've now got 4 cameras selected all at once, apparently. 5. Oh dear. Now near. Okay. Let's spin the microphone around so you can hear me better when I'm over there. Okay. Yeah, it's not too bad of you, is it? I may even change to the HDMI camera, like the actual one I'm using to record with. Did I pin it or not? Right. Let's get the camera going because I need to record this as well. And I may actually is the HDMI going to work? It's got a tendency to not work. Oh, it is working today. Excellent. Don't need to see on screen stuff, do we? Maybe I should use that. Eh? Then you can see what I think you should see, and I can see what you can see at the same time. That makes sense? Oh, maybe. Right, let's work on this thing. So this is a Heathkit. How can I say it? Heathkit. Is it IT 7400 or something like 7400 anyway? Yeah, IT 7400, which is basically a manual IC tester. I'll turn some lights on as well. And so what you can do is put a chip in there and you can manually test its inputs and outputs. That's basically what it's based on. I got it because I thought this looked quite curious and it may be handy one day. I've got these automatic testers, but sometimes they don't recognise the chip or whatever it may be because it's not in this database and things like that. So I thought I'd get this because this may be handy to actually do testing on a manual chip. If I'm not sure about something or it's not in the database, maybe I can use this to check some basic functionality of a chip. It's just purely logic states, so it's nothing you know, analog really, as far as variable voltages or ADC stuff like that. It's just purely logic on or off. So it's got limited use, but I thought it was an interesting little thing to get. Although you can see it's not that little, it's actually fairly big. So yeah, but it needs a bit of work. I don't think there's actually much inside it to work on, but there's a few things we need to do to it to make sure it's usable. So I need to find the manual for it. I need to get that up as well. Let me just find that. I'll probably try and chuck that on screen somehow too, actually. See how we go for views. Heathkit. Although Heathkit can be funny about stuff, apparently. Just opening it up now. Right, it's kind of it really. Right. I don't know how well it's going to come up on screen. Yeah, that's what I thought. Right. Let's show this over here. It actually fits. How's that view? Does that look okay, or is that now too small for the HDMI, you think? Anyway, this is the basic diagram. So we've got power supply section here. It generates 130 volts here for this neon sort of supply, and then it's got this other supply here, which is actually switchable. It's got a 3.6 volt or 5 volt switch. So 5 volts that bypasses the diodes, a 3.6 volts that goes through those two diodes to drop it. Obviously by diode drops, if I can even pronounce it. And then it's got this switch here for stepping, so that's if you're doing a pulsed input, like you're trying to test something which is using a clock signal, so you can manually step it and actually pulse through it and check the steps and like changing of flip-flops and things like that, or counters. So there's got a few capacitors in here, so there's not actually that much to do on the refurb side. It's like 4 capacitors maybe. And this bottom section here is the example of the switches. So it's got a bunch of these switch setups, and these are basically all exactly the same. So I've got a neon indicator here, which has got 120 volts on one side of it, so I have to watch out for that. And it's got banana jacks. There's a switch for different states. You can choose 5 volts, step, off, or low. It's got 2 switches. So this one goes between high and low as well. And also you've got a transistor switch here to switch the neon on. So it's actually isolated. So it looks a relatively simple circuit. Anyway, so I don't know, is that big enough? Yeah, actually, it probably is. Can go a bit bigger. There we go. How's that? That'll be my wife. I need to reply to that. She's talking about getting another cat bed. I've still got 2 cats left. The last 2 cats. They're the sisters of the one which died the other day. So they're all very old. Nearly 20. So I was getting another cat bed, but we've already got like 5 of them, so I don't think we need any more. It's the same as the other one. Apparently there's one particular bed both my cats like. So they're both trying to get into the same bed, but they take turns. One kicks the other one out. Anyway, I don't think we need another cat bed. Right, you think that view's alright? No one said no. Lost 5 teeth, wow. Oh, a glitch then, that was interesting. The thing with animals, don't underestimate this. The food you give them is really important. Like a lot of people give like dog biscuits and whatever it may be. This dried food, and they just give them that. That's all they ever have. If you give them raw food, like raw meat, like from proper pet food stuff, like chicken bits, things like that, they do a lot better on that. My cats are on raw food, and the dogs used to be when we had dogs. They're all passed on now as well, and they do a lot better. Anyway, right, let's go and tinker with this thing. Okay, just gotta get my head in the right space so I'm thinking about the right things. What I've got to do, this needs to go. I need to convert to 240 volt. I think. No, it's got a switch. That's alright. Okay. This needs to be power cord. Let's get some more lights. There's always more lights. This might be too bright now. I need to adjust this a bit. Right. Okay. One last check of the chat before I get committed. Yes, it's a Logic IC tester. Okay. So records the video. In fact, before I record the video, let's try and get a shot of this thing. The glare is going to be a problem, I think. Yeah, glare is definitely a problem. Well, I'm going to work on this Heathkit IC tester. I've had this sitting here for a couple of months now, and I really need to get rid of it so I can get some space in this room. It's getting a bit clogged and crowded. So I need to do a refurb on this thing. It needs a lot of work. I haven't even powered it up yet. This is basically exactly how it came. I don't even know if it works. I've got no idea. It's got the wrong plug on it, that sort of stuff. I need to rewire the mains cable. It needs a new cable on the back here. It's got a switch on the back for mains voltage, so I've already switched it over to make sure I don't forget. But basically, you put an IC in here, and it's called a 7400 because it's actually originally came with a 7400 IC. And it's got this ZIF socket, which is a bit of a strange one. Right, that's kind of pulled up, and it sort of, yeah, it's a bit of a strange socket. It kind of pulls up like that. It doesn't move very smoothly now. And then you push it down to actually lock the pins together. It's a bit of a strange setup. I might need to see if I can maybe put some silicone or something in there to help that slide. It just feels really tight. So you've got these switches. Each channel is basically a pin, and all exactly the same. So you've got off state here, and you've got on this switch, so there's off, that's step, which is using this button at the top here, and 5 volts. That's if you're using that side. If you're using this side, we've got ground. So you've got ground, and gas discharge, which is a little bit different. Okay, so that means it's using this, I think. I don't know for sure. I haven't used it because I don't know. That's my basic understanding. So basically, if you have it there, you can leave it in that position and you can switch between 5 volts and ground by switching that over like that. I think I've got that right. We've also got these high voltage connections here. I don't know what the stories with them. Power switch, and there's a voltage selection switch just here. which is between 5 and 3.6 volts, depending on the type of chip you're testing. Yeah, so interesting device. So it needs a bit of refurb. What number is this? I can't really read that too well. I'll read the serial number. I think it's 04950. Yeah. Anyway, let's get this thing opened up. So 6 screws. I'm having problems with my remotes. Doesn't matter which remote it is, they're not turning the camera on all the time. Or off all the time. Being a bit annoying. Try to do battery and stuff like that. I'm starting to worry it's the camera. Right. No bugs flying out of me, that's always a good thing. No signs of cockroaches, that's always a good thing too. You never quite know what you're going to find inside things when you buy them offline. So, we have, obviously, individual circuit boards for each switch section. We've got some resistors across the dash, the indicators, and you've got a few capacitors on the back here which are going to be really easy to replace because it's the way it's been done. So that's excellent. We've got some old of these. We've got some of these old resistors here. They will need checking to make sure the values aren't too bad. We've also got some newer ones which actually look fine. So it's actually looking pretty straightforward. This should be a nice easy refurb. Excellent. What's on these? I don't think any of those old resistors down there. That's looking alright. I think all the tricky stuff's on the back here. Okay. I'll chit chat, then I'll do some more. I'll keep it bigger, eh? Right. I'm going to plug the regular ZIF socket into the existing socket. Well, that's an option. I might have one. I'm not sure I've got the one with the right number of pins though. I know I've got some ZIF sockets. I'm just not sure I've got one with the right number of sockets, pin connections. Let's get rid of these emails because it's bugging me. They can go. So I don't keep getting prompted to look at it. You want full screen? You're not interested in the circuit diagram anymore? There you go. Alright, soldering on. Actually wondering if I should change bits to a bigger bit. This is all tag strip stuff, so there's a bit of thermal mass there. I think I'll change tips actually. I don't want to use this tip because it's massive. I've got to be carried away, I think, with that one. I tidied up my desk the other day and I've got the stuff not quite in the right places. It's just out of a place enough to be annoying. Right. So we could test these capacitors before I pull them out. Got to test those resistors. I think there's only two. Yeah, there's only two of those old style ones I can see. So that's pretty good. So let's get my capacitor tester. Let's use this one. I've actually got a stand I've got to print for this thing. I've got like a, I don't know if it's one I designed or if it's someone I found, I can't remember. Maybe it's one I found and modified, I can't remember now. But it's a little stand to actually pop these things up so you can actually see them on camera a lot better. I've really got to print that. It will stand about that angle, which would be about right, I think. Yeah, I really got to print that. Spiky connections. So I stab myself. Let's see if I can move this way you can see it. That looks better, no? Like that. Still reaches. Right, let's test these capacitors out. Let's see what we get. Although I'm going to replace them anyway. 13.2 microfarad, 3.2 ohms. 13. I think that's a 25. So that's a bit bad. Actually, it might be even more than that. Might be 25, surely. 350 volt. Oh no, I can't quite see what it is. Actually, it's around the side. Look at the wrong markings. 10 microfarad, 350 volt. Let's try this one out. Thousand microfarad, 0.2 ohms. Well, the resistance on this one was bad. Let's check this one out. 1000 microfarad, 1.42, so that's looking a bit worse. Considering they're the same caps, that's quite a big difference. Let me check this one. Come on. Get onto it. 1000 microfarad, 0.8. So I think these two are the bad ones, basically. But I'll see what I've got in stock. That's a 350 volt. Not sure if we've got any high voltage actuators like that. I'll have to see. But I mean, these are 25 volt, 500 microfarad. So I basically have to replace those to 470s. And this one here is a 1000 microfarad, 15 volt. So not too bad. Should be straightforward enough. I'll see what I've got. Don't ask me, bastard. Oh, I think fell off. There's not anyone here. Let's see, so we've got, let's say it was 10 microfarad. I like to just replace and done with it so it's finished, you know. All these. 450 volt, I don't actually have a suitable replacement. Cool, that one. And you want 500s or 470s, 25 volt. 35s. What are these ones? 16s. There's a 25 there. Another one there, different styles. That's fine. Yeah, use the same type there. And that one's a 1000 microfarad, 15 volt. Come on, get back in the drawer. These are 1000. 16 volt. I do. This is why I have all these capacitors I buy. Well, I haven't bought any for a little while actually, but this is why I buy these things. So when I do a repair, I've just got the parts on hand. It's much easier this way. So I've got the parts I need. What I'm thinking I might do is unclip them, because they're probably wrapped. Yeah, I can see the resistor's wrapped. I can see that's wrapped. Unwrapping them could be tricky. I mean, I'll try and get them off, but I'll probably just end up unclipping them and putting the other ones through the holes when I heat them up. I think so. Right, so it's all the parts I need anyway. I mean, some people say, oh, why replace capacitors if they test okay? Well, they test okay this week. I'm still going to test okay in a month's time, next time I try to use it, or 6 months' time. Probably not. Chit chat. Yeah, so many pins is this thing anyway? Is that 16? Yeah, 16 pin. So I think I do actually have some 16 pin ZIF sockets. So it could actually be an option. Yeah, there's a little bit of tarnishing in there too actually. I might actually give that a spray. Must not forget. I'll get the deoxide out now, so hopefully it prompts me. Yeah, I'll stick it there. That should remind me, hopefully. Hopefully. Probably have to clean that switch as well, think about it. Should probably just spray all the switches. I'll do that as a separate bit in the video. Once I've got the other stuff done. Right. It's a bit slightly, I was going to end up being out of shot probably. What's the focusing like? I haven't looked at it yet. It's a bit slack, isn't it? Focus better. It's pretty much there. Good. Right, let's try and get some of these capacitors out. So this is the first one I'm going to take out. I'm just going to go down. Go anti-clockwise, I think. So we can get these out now. The problem is these are wrapped connections, so they're likely to be hard to get out, if not impossible. But I'm just going to give it a go first, see if I can get anywhere with it. Might get lucky. Actually, let's just get my fan going. Put some fresh solder on. And I'm using a massive tip here because of the size of these connections. Large single mass. That is, yeah, that's definitely wrapped, but I can see the end of it, so there might be a chance to get that one off. Let's see how we go. This is a very stiff lead as well, just open. See it moving around there. poor tweezers. There we go. Got it. I'll put that capacitor back on again. Right. That was a challenge. But now one end's off, I should be able to get the other end out easier. There we go. So that is a 10 microfarad 350 volt. And I actually have a 10 microfarad 450 volt sitting right here. I've got all these parts in stock, so we can shove these in. I'm going to try and shove these to the wire wraps as well, so this could be a bit interesting, but we'll give it a go. Yeah, that's free through there, excellent. Get these sold off, the drips everywhere. So that's floating through the hole, which is perfect. It means I can try and get the other one in. Which I'm trying to do kind of backwards. Tweezers. It is where it went, wasn't it? Right there. I hope so. Yeah, double checking stuff. Make sure I haven't got mixed up. There we go. So I put this so I can actually read the values as well. So I'll try and put it like that. This capacitor here needs sorting out. Be fine. Just do that with it. Let's make it hard for the next person or not. Come on. Big blob of solder, but then you need that on these wire wrap things, otherwise they tend to break free. Right, that's one capacitor done. I'll repeat that for the other three. I don't have to record the whole thing, do I? Come and check the chat. Got a Fluke 8000 to repair, looking forward to that one. What's a Fluke 8000? Not familiar with that. Hey Michael. Now I'm going to have to go and look it up. If I've come across a number I don't recognise, it's like, is that something I should be buying? Cable analyzer. Interesting. DSX 8000, I'm guessing that's what you mean. Right. So I'm going to record more videos. I'm going to take these off. Not to worry about them. Come on. Not getting a very good thermal connection there. This tip is really massively big. It's a bit ridiculous, really. Which is the wire and which is the lead? Okay, I'll just cut that bloody thing. I think this tip is just ridiculously big. It's changed to something slightly smaller. The only problem is that the reason I got that tip is because the tip which I did have for doing heavy work decided to die, and as a result it made it a bit hard to actually work on things. This tip is a bit small. I might be able to go over it. Okay, there's the wire lead there. That's it there. Solder splash with that. Come on. Okay, positive to the left, and that's a 5000 microfarad, which will be this one, right? Yep. Come on, get in. I'm using my really fluxy thick solder here for this because I'm trying to get rid of it. I prefer the thin one I've got, but I don't want to waste this, so it's gradually coming down. It's taking me a while. But for this sort of job, I suppose it's actually really good. It doesn't have to be silver solder for this particular work, so that's fine, really. Now you guys have to watch out for me making a mistake and doing things like putting a capacitor in backwards. Now I know you guys would like magic smoke and explosions. I prefer not to have that. Do this one here next. So this tip is struggling a lot with this. I don't want to put the heat up because it'll end up melting insulation wires and stuff like that, so I'm trying to avoid doing that. That popped out nicely. So positives to the right hand side. You notice these capacitors have got the arrows pointing the other way. Right, so the marking is towards the positive side, not towards the negative side. You see it? Some old style caps got that. Like the first one I pulled out, arrows going to the negative side. This one here is positive mark this end, but the crimped end is the positive end. So positive end there, arrows pointing towards positive, not towards negative. Watch out for that, because it also says positive, not negative, even though it's got a band on it. Yeah. Where did I take that from? Uh-oh. Was it the orange wire? There? Was it the orange wire or the diode? I think it was the orange wire, wasn't it? Yeah. Which one's hot? Yeah, orange wire. Okay. I think. Oh, which one did I take that from? Oh dear. Is it there or there? I don't remember. I think it's the orange. Was it? It must be. There's nothing else on there. Okay, right. This thing goes through all these resistors, so I might actually check that resistor before I resolder the next one in. Come on, come out. This one's really stubborn. There you go. Go through, that's fine. Let's measure this resistor here. Since it's the same lug I've got to resolder, I might as well do it now because I'll have to change it. Out the other way. So I'm just going to measure the resistor, which is here. Got a couple of resistors which I need to check for. These older style ones, these do go off value with age. So I'm going to get a closer shot. You see them just in here. These two, those need checking. So I just need to measure that to make sure that it makes sense. That's what we've got here. 23K. Band markings are red, violet, orange. It's 27K. Let's check the circuit diagram. Where are they? That's R7, I think. Yeah, 27K. It's got a lower value, which is interesting. It could be getting some bypass from the other circuitry around it. Right. So I think that's probably fine because it's reading a lower value, which means it's probably got some other circuitry bypassing. It's connected up to the regulator here. So this tab goes down to the regulator, which is down the back there. Maybe you can see it or not. It's connecting to that, so it's probably got some bypass through there. So let's measure this other resistor here and see what this one comes out as. I wasn't thinking about it. It's also measuring 23K. Anyway, that's brown, grey, orange. So that should be a 18k. Now that was measuring higher, so that's not a good sign. Do I have another resistor? Do I have another resistor? Seriously. But do I have a 1 watt resistor? I've got half watt. Does it need to be a 1 watt, really? What's it doing? Let's have a look at the circuit diagram. I'll show us the top screen. Top screen. Oh, it's broken. Of course it is. Why is it broken? Oh, it's behind it for some reason. What's it doing there? It's weird. Yeah, I don't know. Right. So there it is here, coming past, bypassing between the emitter and collector of that transistor. So that's the first one, 27k here, R7, and that's the 18k here. 10% tolerance resistors apparently, so it can be 20k or 16. Oh, Johnny's gone. Catch that, John. Anyway, so yes, that's what we need to look at. Let's see if we can swap that out. I mean, it's 10% resistor, so it's pretty good. Let me see if I've got something else I can shove in there which might be 1 watt. 16s, no, I don't have a quarter watt. I've got 20 and 22k. Let's have a look. 20k will be just in spec if I can get the drawer open, because I've got so many resistors in it. Come on, let's go. So I've got some big ones in here. But are they the right resistance value? Is it marked on there? I might have to read colour bands. I might have to. These are big ones. I think they're what, 2 watts maybe? Yeah. That's what we're looking for. That's 22s. Those are 22s. That's too much. What's that one? Good question. What is that one? There's lots of colour bands in it. Let's just measure it, be easier. And get the probes on. 19.7. Yeah. I think it's only half watt though. Well, a third one needs, but these are 22s. Why is it I have all these parts and I still don't have the right ones? How does that work? Seriously, how? How does that work? Pretty sure it's only half watt resistor. I can't really put that in. I mean, why has he got a resistor across here anyway? That's weird. It's got some biasing. That is strange. Anyway. What should I use? I've got 22s. It's just too far. It's like 20% out. It's only slightly better than what's in it. Not keen on going that far out spec. What have I got as far as 37s? Those are not really going to do the job either. Each of these would be half watt resistors. Does that mean those are 1 watt resistors? If they are 1 watt resistors, I might be able to do it. I can't bloody guess what size to go. Maybe it is a 1 watt resistor. Maybe I'll just go one of these and just hope for the best, see how hot it gets. Maybe I'll just check it and see what happens then. I'll put an 18 in there and we'll see what we get. I don't think down to 27s, which are correct. If that one is bad. The 120 volts used for neon indicators. So yeah, that's a significant resistance size difference though. Yeah. Yeah. Not sure about that. Still doesn't get what's in there, isn't it? So yeah, just change it. Okay. Stop rolling away. I think I need to kind of float that resistor there and just be sure that one's okay. I was measuring a lower value than it's supposed to be, but it could still be off value. I need to unhook this end and float that into the resistor. Then it could be interesting there. Come on. Melt. Come on. There we go. I'm going to retest this one because I'm not actually, I'm not confident it's okay. If it's a different kind of resistor, I'll be, you know, less worried about it, but these aren't great. 28k, that's fine. It's 1k high, so what? It's fine, it's what we inspect. So I just pulled out this leg of resistor, I can't say. I just pulled out this leg of this resistor here and measured it out of connection, so it's not actually in the circuit anymore, and it's only 1k above it's supposed to be, you know, what it's supposed to be reading. Bloody hell, it's trying to send this together. It's only 1k above the value it's supposed to be, which is supposed to be 27, it's reading 28, so that's within spec, that's fine. I'm not worried about that. So I'm going to put that one back in again. And I can refit this capacitor. Hopefully. We should be good. If I can get all this through. Yeah. There. This one does need changing over here though. That one there definitely needs to be changed. Come on. Come on, with the fitting, don't trip off. Go back to that one. I think I need to rejig it. So I think I should be using a high temperature on his arm. Yeah, it's probably right. Okay, so now I've got to do this capacitor and this resistor. Let's do the capacitor first, I think. I'll finish caps off, then I'll finish that resistor. Right. And yeah, I'm going to put the temperature up on the iron. This is struggling too much. Come on, unwrap the bastard. There we go. Was around the outside of that post. There's no post there to go onto. That was weird. Made it harder than it needed to be. That was easy. I know it's not in focus. It's not going to adjust it right now. Give me a second. Alright. I'll get this one soldered on and I'll come back and check the chat. Get the light on it so you can see a bit better maybe. Alright, let's come to the chat. Right. Lots of checking, great. And Radio Shack and Tandy, yeah. I used to spend a lot more time in there. Well, I used to love going there. Unfortunately, the Tandys in the UK was quite a distance away from where I lived, so I didn't get there very often. But I would spend hours there once I did get there. You can't get caps anywhere. Yeah, it's completely my fault. So those capacitors replaced. Now I've got to change this resistor. Now, unfortunately, the only one I've got is actually a lower wattage, I think. I'm not entirely sure. I think it's only half a watt instead of 1 watt. I'm not quite sure how that's going to go, but this resistor is no good, so that's what will come out anyway. I'll put the one in that I have, and we'll see if it gets too hot. If it gets hot, I'll have to figure out something else. You know, maybe make up something else, but we'll give it a try first, in case it's fine. I think let's just poke through. It's just poke through. Great. So that's that one. There you go, from the other resistor. Don't forget where it goes. And this then goes to the red wire. Not ramped. Awesome. Actually, let's test this resistor now. It's out of circuit, although it's warm, so it's going to be reading slightly higher because it is warm. $19.2K. Actually, it's not that bad. Maybe I healed it a little bit by soldering it. I definitely measured 23 in circuit. That was interesting. Interesting. This resistance value is actually going up as it's cooling. So maybe I'll let that cool down a little bit more. Just shoved in front of my fan. Oh no, it fell off now. There you go. Just let it cool down a little bit. I keep losing the other one I'm going to put in. Yeah, I'm just worried about the wattage. It might be a 1 watt resistor. It could be. Anyway, might set some time to cool down. Let's see if this measures high again. 19.4. I mean, that's actually alright. I definitely measured 23 before in circuit. I don't trust it. Let's take it out. Let's put mine in. I've had that before where a part's been measured bad in circuit and desolder the measures okay. It's like, no, I don't trust it. So, there's no holes there to shove those through, of course not. Come on. Slightly awkward angles. Got to clean my soldering iron mount. The iron keeps on triggering as I'm putting the thing in. It's a bit dirty because it gets a contact there to know when the iron's been put in the holster. It keeps on triggering as I'm putting it in. Obviously dirty, didn't used to do that. Let's pull that one around. Shove it through like that. Okay. Right, solder you bugger. Okay, that's all appears to be on. Okay, is that done? So resistors dealt with, capacitors dealt with. Right, that's half the job done. Well, more than half the job actually. Now we've got to do the power cord, which should actually be fairly straightforward. Come on, chat. Okay, Adam. Thanks for dropping by. Probably gone by now. Adam Brady not made anymore. Yeah. Carbon composition resistors. Hey, Peter. Right. Okay. So, power cord. I need a cord to use. Let's find one. Now this will need earthing, I think. I mean, yeah, it is earthed, so yeah, it'll need earthing. Pick up some of these cheap Chinese ones a while ago, which I did a mailbag, and I think this might be the time to find out how good they are. It's only quite a short lead too, it's only about a metre, which is fine I think. Let's turn off a minute. So I picked up these little power cables off AliExpress a little while ago, and they feel a little bit thin. They say 10 amps on this end, and they say 10 amps on this end, but I don't think it's a 10 amp cable really. Markings say 3 by 0.75, so yeah, maybe. That's what it says. What is it though? So I'm actually waiting to have a situation where I need to cut a power cord off to replace one on a piece of gear. So now I actually have a reason to cut one of these apart. So I'll cut the end of this, and we'll do a new mounting and stuff on here and find out how good this cable actually is. So bye bye cable. Now we plug this end in. No, not yet. Obviously not. You ever plug a mains cable, make sure it's not plugged in first, otherwise you'll have a really, really bad day. Maybe a bad several months after that if you've been unlucky. Anyway, so this is like tearing. This installation is not actually, this is tearing really easily. It's not very good insulation, and the wires do seem thinner than I think they should be. I don't think that's 0.75, as I suspected. I don't think these are true statements on these. I mean, it is copper coloured. They're not steel wires, so they're actually twisting. Or aluminium, maybe. It could be aluminium still. But steel ones are for, which just don't twist. They just keep popping back out. So, these might actually be copper. There is that in them, but I think these aren't 0.75. I think they're slightly smaller than that. Might be 0.5. I think they're slightly underrated, which is kind of what I expected to be. Not quite what they say they are. Anyway, let's just solder these, so that will fray out everywhere. See if they solder. Oh, it's soldering, so that's another good sign. I've had steel wires which don't solder before. So they're kind of right. They just seem to be a little bit thinner than I think they should be, and the insulation in the outer doesn't seem as tough as it should be. Anyway, that's that. Let's pull this apart. So ground there. Is this phase neutral? Does it really matter? Switching through the fuse, switching the fuse line. Going to there, doesn't matter, goes straight to the transformer. It goes out of there, straight to the transformer, does it? Yeah, so that's switching through the voltages, so yeah, okay. It's going across to there. So in that position it goes up to that side. In that position it goes to that side there. Goes to there. And to there. Right. So phase neutral doesn't really matter. I think I've got the phase going to the side of the fuse, which is also switched. I'm happy with that. I always switch the live hot side, whatever you want to call it. I think it's just good practice, because neutral was potentially the same potential as ground in most situations, not always. So yeah, let's do that. So I followed the wires around, and this side here, which is switched, goes through the fuse, so I'm going to call that the live side. It goes to the transformer, so I'm confident that I can just put the live or the hot wire, whatever you want to call it, to that side of that fuse, and the neutral will come down to this switch leg here, and that just goes to the transformer as well. This switch here is for the high voltage, like 120 volt, 240 volt switching, So that's what that's for, is changing the winding connections on that transformer. So yeah, I'm confident I can just go to that as a live hot wire and replace the cable. Earth goes straight to the chassis up here, nice and easy. So I'll take this off first. I'm thinking maybe I do need to put the bigger tie on to back on here. So we go. Okay, and flick the big bob of solder out. Let's get that off. Got that floating around in there. That's that one. Get the earth off over here. Just got the tweezer to be easier. Take the earth off. And then you've got to get the neutral off, which is from the switch, which means it's probably wrapped around the switch. We'll see. No, it's not. Excellent. Now go get this gland out. Chat to chat. Hey David. Hey Ray, didn't know you were here. Right, okay, tools. I have a thing for this now. Sounds really bad. I have a. No, that's not right. Is it anywhere? Where is it? Here it is. So I picked up this tool here for doing glands, but I'm not sure actually if it's good enough. I actually don't like the angles on it. Closer, there we go. So you can see those, as you put it closer, it angles off. And the size I tend to use is about there. So it's kind of parallel, but it's not quite. It's very slightly off angle there. And you notice these are actually quite thick. So they're not actually getting behind the glands very well. So I think I actually might need to I think I actually might need to do some work on these to make them a little bit better. Yeah, focus on this thing. Yeah, focus on that. Ish, in there somewhere. Right. So let's see if this gland tool is going to do the job. It may or may not. It did it this time. I've had problems with this not fitting too well in some cases, so I think I actually want to modify this thing. I'm pretty sure I can't reuse the same gland. I don't think it would be suitable for this cable because it's somewhat thicker. Let's have a look. I'd say, yeah, nah. Yeah, nah. So, get another cable gland. I've got some here somewhere. That's where I'll find them. I think I might need this one. Maybe. Seems a little bit loose actually. It is grabbing slightly. These ones are pulled out bits of gear. Running low on these things. Yeah, I think the only real size I've got are these big ones. Yeah, I think I need to get some other ones which are slightly smaller. I don't know what size these are. They're probably rated 8mm, are they? It says 6P1 on that, I don't know. So yeah, I've got this one which is kind of going to do the job. I need to make this hole a bit bigger. Need to buy some more cable glands. Yep, okay. Now I need my reaming tool. Tight a little bit, I'm getting a bit messy here. So I've got a cable gland which is just the right size. It's only barely good enough. It's slightly on the large side. I actually like 1mm smaller really. But it's going to do the job, I think. Now the problem is this gland is much bigger than the hole it'll go into, so I need to make this hole bigger. For that I've got this reaming tool just here. And I'm just going to stand this thing up on its back, or I'll probably stand it like that probably, and then ream this out bigger with this tool. Make sure there's no wires or anything in the way of the hole, because there are some close to it. Move those out of the way. Don't rip through the insulation, and then I'll just keep going with this until the gland fits in. You don't need to see me do that there. Oh, maybe I'll just do a little bit. Yeah. Problem is this will no longer be a keyed hole, so it's going to be a round hole when I do this. You can see the key's already gone. And basically I'll just keep doing that until this gland will fit. Got a long way to go. So what you could actually do, if you really wanted to, you can actually, like, do what I'm going to do now, because I'm getting close, is actually ream it at an angle like this, on two planes. And it actually does give you a slightly elongated hole, which does act a bit like a key. Try that. Still not there yet. You see now it's slightly oval. I should probably record that. Go on, remote work. So what I'm doing now, because I'm getting close to the right size, I've actually started to elongate the hole, which with this reamer, all you do is basically stick at an angle like that. So you do that side, and then you turn around this way and do this side. Obviously you've got to watch out about what's inside, make sure you're not reaming through something inside it when you do these big angles. But you have to make sure you're doing like this, and that will then create an elongated hole, which gives you a kind of keying to get this thing into. Now I'm really close to the right size now, so I think the elongation's about right, so I might actually now just do the middle bit again, because it's not quite wide enough in the middle. And we'll just keep trying, just tweak it until I'll just keep tweaking it until I get that to actually fit. It's getting very close. Don't overdo it. Might be able to go that way actually. Yeah, slightly more. Might be just about there. Almost. Now I have another tool for this. Reaver tool. So if you want to screw it up some more, you also do it like this. Right. Should probably record this too, should I? So the other thing you can do is you get those reamer tools, and you can also square the hole up a little bit like this, just by doing those little corners where you want it to actually just grab it, just to create a little bit more clearance. Okay, you can do it like that as well. When you get really close, you can just do it with these little bits, just to tune it, and just take away a little bit of metal like that. Of course you can always use a file, but you know, that's also possible. There you go, it goes in there now. I think it goes in a bit too well. This one didn't go too big. Should hold when I've got the cable on it. Alright. That suddenly changed size by quite a bit. Now I've got a bit of aluminium to get splinters from. That's always fun. Right. So I always like to give a decent amount of clearance inside, so it's got plenty of slack, so if it does move, it will be okay. The other thing technically you're supposed to do is have the earth wire longer than the rest. That still may be possible. I could always cut these down again and re-tune them again, but trying to just get this length long enough to not be awkward as well. Yeah, I think about there is probably going to do it. Okay. Yeah, it's not really doing it, that cable gland. Right. So what I could do then, that's what I want, is I put some sleeving over it. Come on, come back out. Put some sleeving over it to make it thicker here. That'll do the job. Actually, I must use heat shrink actually. Will do the job. That's nearby. right size. That feels like it would go a bit better now. Always do another layer on if I need to. I think I need another layer. Probably stick another one over the top. Make sure it's going to fit. Yeah, we'll just go. Come on, keep going. Right, that did the job. We prefer to have the right size gland, but yeah, that's the way it goes. Let's do this aluminium filings. Yeah, try this thing soon. Chit chat. Step bits are nice. Yeah, I've actually got a step bit set. I've got some in the garage. Still reading, still reading. It was a paid by beer job. Paid by beer. That doesn't pay electricity bills or petrol bills. It's like the review stuff I get. You know, I get this free gear from time to time. You know, sometimes it's quite nice. Yeah, I'll get some nice free gear, but it doesn't pay the bills. It doesn't allow me to buy things. Anyway. So I've built this cable up to make it a little bit thicker here because I wasn't quite happy with the gland fit. It wasn't grabbing nicely enough. So now I've built it up. This should be a nice tight fit on there now, and that won't be a problem. I'll be much happier with that. This will also double up a little bit, I suppose, as a strain relief to some extent. So anyway, we'll get this back in here. Yeah, that's much better. That's not going anywhere. Happy with that. The other thing to do as well, if you want to be absolutely sure, you put the cable tie around it as well on the inside. Do it up really tight, so it's got even a bit more, which has to try and pull through before it starts pulling on the wires. It's probably a good thing to do. But these glands, once they're locked in well enough, they basically put the thing through like a little detour, like a detent through it, meandering path through the actual gland, so it actually forces it to tighten up more as it gets pulled. That's how they work. Anyway, we'll get this hooked up. Also, check this fuse out and see what fuse it actually is. Something else we should probably do. Can I thread that through the hole? Maybe I can. Yes, I can. Happy with that. May put some fresh solder on this as well, just to make sure it's going okay. Yeah, definitely needs more solder on that. It's definitely nowhere near it. It's funny how the angle makes a big difference. Ask your wife. Yeah. Oh no, I've ruined it now. Let's just put some fresh solder on this. Get this all plated up nicely. It's got a little edge where actually had any solder on it. Try and get it going. Come on. Come on. It's not need to scrape. Shouldn't really use the soldering iron tip to do a scrape. No, it's starting to go now. That's right. Let's put that through again. Happy with that. This one will do the same kind of thing. Made harder by trying to record video at the same time. And to show what I'm doing. It's a slightly more awkward position I would like to be. Come on, get in. Come on, get through the hole. It's not actually through the hole yet. Yeah, come on. It's not so very awkward. Here we go. That's through. Let's fold it over a little bit. And make some fresh solder on. Yeah, I'm not too happy with that. That looks a bit ugly. Yeah, I do. That's better. So now I've got to get the neutral on, which is potentially going to be a tricky one because of the switch. See if I can get it through there. Yeah. I think I need to prop this up. Push through. There we go. It's through. Lovely. Let's push a first solder on that. And just about the point where we can change it. Change it. So just about at the point where we can try it out. I suppose I should do some safety checks first, shouldn't I? Make sure it's not going to like short out and electrocute me or something. Chat again in a second. Yeah, when I built my garage, I wired all that up myself and did everything basically. Wired up to the house because it's like a sub main. Wired up to the house as well, ran a cable through, you know, buried a cable, that sort of stuff. Did all that. And a mate of mine's an electrician, so he come and checked it all and signed it off. Once he's happy, it was all good. He knows what I like. You know, well, he knows what I'm like. He knows I'm quite capable of doing stuff properly, and he just came and verified that what I did was up to his standard, and that's fine. Obviously, he did all the tests as well, the ground tests and isolation tests and that sort of stuff. I've still got the KSGR. That's out in my other lab. I use it out there, and yes, I'm using a JBC clone. It's not actually a JBC. Works really well though. Pony boxes, alright. Yeah, basically it's got a sub-supply, like a main box in the garage, which is a spur off the house supply. So this house is the main one, which is RCD'd and everything as well. Everything is RCD'd off the house, and then that goes out to the garage, the 32 amp circuit, and that's all RCD'd as well. So, yeah, sub panel, yeah. Anyway, let's power switches off. I just want to do some basic like cable checks and stuff like that. Make sure there's nothing horrendously bad. $250 will do. Don't touch it. Nothing wrong there. Nothing wrong there. Nothing wrong there. Cool. So I should also check for shorts to the actual case. There should be a connection anyway. That's fine. There. There. And the earth should actually be a connection. It is. That's fine. So the insulation side of it looks alright. I've only done 250 volts. But I could actually do 500 on this. I could actually do it because the switch is off and it's isolated. So yeah, I can actually do a high voltage test. Let's do it. Yep, fine. And the other way. Yep, no worries. And to be absolutely sure that yes, it is actually working. There's 250 volts. And there's 500 volts, both showing shorts. Should have done it before I started, really. I've had this thing for years, this meter. Years and years. I don't actually get to use it very often. The thing about getting a flasher one, you know, some digital thing that I thought, well, I barely even use this one. Barely use it. Still like new condition. Anyway, so it's not going to short out and blow up my face or anything, so that's probably a good start. So we shall carry on. I'm going to leave the back of it open for now. What is that fuse that's in there? I shouldn't assume that that's got the right fuse in it, should I? Pop out. Don't break. There you go. C to 50 volt. That is a half amp fuse. So it's not horrendous. What's it supposed to be? Half amp? Yep, that's fine. So we should be able to plug this in now and try it. Are you ready? So let's power this up and see what happens. Nothing went bang. That's a good start. Turn the power on. We have an indicator over here already. Should there be? Maybe. Oh yeah. So I'll do 5 volts on all these. They should be on. 5 volts. Yep, okay, we can verify the indicators at least by doing that. Oh, we've got one which, oh no, it is on. Let's just give everyone minutes. So you can probably see those indicators, all the indicators light up. Power indicator lights up, but that's good. So that should go off. That one hasn't gone off. Might need to clean these switches. That's why I also struggled to turn on when I first got it going too. So maybe the transistor switching on that one's a little bit dodgy. I don't know, actually no, there might be some gunk in this switch. I think the switches need cleaning. And it's also at 3.6 volts, let's try 5 volts. I think it makes no difference in the brightness, so that's fine. Okay, well that seems to be basically working in that state. We should try a chip. What should we try? What do I have? 740. If only I could read the bloody markings on it. Siglent LS00N. Perfect. It's the chip that's supposed to be using it. Well, one of the chips. So each pin is individually controllable. So I need to make sure I get the power supplies right. Just turn the power off for now. Come and check the chat. Oh, I just put a data sheet up. Right. Not drunk, just tired. Right. If you say so. Data sheets. Let's do. What am I looking for? 7400 ICs. 7400. So it's a quad 2 input NAND gate. Show this in the top screen, and you can see it then, like that. Just sort of more here. Yeah, okay. So we can test each gate. So there's a set there, set there, set there, set there. So ground pin 7, VCC pin 14. We'll get those set up first. So ground on that one it is. VCC will be that one. Lift it up. Yes, it is. Actually, I was going to clean the switches, wasn't I? We'll give it a go first. Oh, this is not right. Set up. Hold on. There's one less pin here. Yes, right. It's a 16 pin. It's now 16 pin. So ground here. To watch out for that. I don't mess this up. Ground there. Yes. Pop that down. Oh, that didn't go down well. There we go. Push the switch. Push the chip down rather than the holder. So we've got VCC there, ground there, and this needs to be off. So that is not a connection, that has to be off, like that. I'll do the same thing for the other ones. So that is pin 6 as well, has to be off. So that's this one here. And pin 8. So it's this one here. That's right. That one there as well, like that. Push together. And pin 11. So it's middle pin there, which I think is this one. Like that. Okay, so off, 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 and off. Yep, okay, so that's the outputs floating. Neons will still work because it's controlled by the chip. So that should be ready to test, if I haven't got anything wrong. And this is a 5 volt device, isn't it? Not 3.6, anything like that. Could be 5 volt, wouldn't it? I should verify it in case I'm getting mixed up by something. It's high voltage, up to +7. Yep, no worries. Okay. Suppose you want a big view of the device, don't you? So if you get magic smoke. I should check for leakage. Yes, I should do. I mean, it's going through transistors, and it just seemed to be switching. If I blow a chip up, then I've got plenty of these ones. I've got loads of these. I've got these from China, so it might be no good anyway. Although I think I put them on test and they tested okay. Actually, we go and get another drink. Hold on, I'll be right back. Drink grabbed. Okay. Okay, right, what do we need to do? Train of thought, get that right. Record video, that's what I need to do. I'm going to turn the soldering iron and stuff off now, at least for the time being. Ouch. Wish I had more space. What I might do is turn that off. Is that going to work better? Maybe. Trying to shut the neons. Maybe I'll stand this up. Yeah, slightly better, isn't it? Okay. That's even in focus. Right, so we're set up here. I think we're ready to go. I've got a 74S00 IC in here. This is a 14 pin device, not 16 pin. So the bottom 2 pins aren't being used. I've set these switches up to allow for the device. So the outputs, because it's a quad 2-input NAND. So obviously the outputs from the NAND, you can't have those being pulled either way. So these are in the off states. That's that one there. This one here. This one here. And this one here. Sorry, that one there. So that's the 4 outputs. This is the VCC line, which is going to 5 volts. And I've got all the other lines set to ground right now. So I can basically switch these switches here backwards and forwards to go between ground and 5 volts. And that will then hopefully enable the indicators on and off on each particular output. So you can use this to manually test a chip. So let's turn the power on. I've got it set to 5 volts. And there we go. So you can see, maybe on camera, well, it's a bit hard to see. Let's turn some lights off. See it slightly better. Keep going. There we go. Now you can see it. It's going to be a bit dimmed here. Yeah, it's probably just do that. So it's going to be a bit dark. Anyway, so you can see the neons here. So obviously that one there is denoting that we've got a 5 volt input to the chip, to the VCC line, and those are the outputs. So if I switch these lines, these should turn on and off. So that's now high, that's now low. So that output is working correctly, and we'll do the same for this one. That turned off, that's fine. And the same for this one. That turned off, that's fine. And the same for this one. That turned off. Perfect. That chip works fine. drink. Yay, it isn't a fake. Well, it's functional, but is it in spec? Are the voltages truly correct? Yeah, so if you've got a chip which you need to manually check, then you can just drop it into this thing and do it manually. And there's been times I've had some weird chips and I've had to do sorts of weird things to like plug on and take them out of a circuit and drop in a breadboard and things like that. So potentially what this could actually maybe have is like a link between the socket on here. Just run a cable from that socket and put a clip on the other end and clip it in circuit. I mean, that may be possible. I don't know. Probably be a bit hard. Try 3.6 volts, you reckon? You could do that. You think I should actually measure the voltages? I haven't done that yet, no. Let's actually see what's generating. Someone what? Oh, I've already messed it up. Where is that one? No. I was going to check for AC on it as well. Let's do it in two DC supplies. Let's do it this way. AC and AC. AC and AC. Oh, I thought I could do AC and DC on this thing. I thought I could. Yeah, so you should use this one instead. I know to use this one. That Keysight one I haven't used that much yet. I'm still trying to get grips with it. That's why I've been grabbing it first, basically. Yes, I do have the screen protector on it, even though I peeled it off in the review. And you've got reflections. We need to get rid of them. Just put it over here. It's easy to see, isn't it? So you can do dual display on this thing. Manual, AC/DC. Check ripple. So power on. Negative side, positive side, 5 volts. We're getting 3.7 volts there. That's interesting. That's a bit low, isn't it? No ripple though, which is good. 3.6 is also 3.7. Is that switch not working? Yeah, looks like that switch isn't working. Let's put it again. Come on, get in there. Come on, cooperate. I think I'm messing up the voltages on the chip there because I'm opening the connectors up. So what's going on with this switch? I can't get 5 volts there. Cool video. If the remote would bloody work. Right. Yeah. So I'm just testing voltages across the chip. This should be doing 5 volts right now. We're getting 3.8 or so. And if we go down to 3.6 volt position, it's still 3.8. So we've got something going on with this switch maybe. Oh, I saw it just then. There's something happening with the switch. I did see it flick the 5 volts just then. There we go. 4.2 I saw there. 4.7. So I think we've got a dodgy switch here. So what I might do now is stop, clean all the switches up with some dioxide and see what happens. Tool the power. Now, from the back it's probably best. Yes, it is. At least those ones. And we'll probably get to some of these from the end as well. Yeah, I can. So this will be fun. Lots and lots of dioxide everywhere. Yeah. I'm out of shot, of course I am. The cleaning switch is going to be exciting, isn't it? This is the power switch I'm doing right now. Okay, next switch. Let's try and get into the top of this one like this. Kind of works. This is it. Voltage switch. This one here shouldn't be a problem. This is a mercury wetted switch. Special switch. Right, let's spray all of these. Make sure I reset these back to the right places when I've finished. I'm not quite sure I'm going to get these other ones. These are a bit trickier. Ground. I've forgotten the pin out now. 5 volts. Off. Is it? No, ground. Ground. That was the off. That was the off one there. Right. So that's that row. Getting to these ones could be trickier because they're not really in a great spot to get to. I might be able to get in there with the nozzle actually. Might just be able to get in there. I'll get to it from this side. Oh yeah, I'll get to it from this side. Let's do it this way. Maybe from there. This bloody can's leaking. That's helpful. That's what you want to do is waste your dioxide. This stuff's not exactly cheap. We're halfway there. God, this can's dripping everywhere. It's not very good. putting more on the bench than I am on the bloody switches. I'll check the chat again in a minute once I finish cleaning these. Obviously got to do the socket as well, yep. Alright, this one's not there. Yep, okay. Oh man, it's got deoxit all over the bench, it's fucking awful. It's just like everywhere. Yuck. Why is this leaking so badly? Ones. Then we're done with the switches. Bloody hell. I'm going to have to clean this bench. Right. So switches, I'm not going to worry about the BNCs, well BNCs, the banana jacks, I'm going to worry about them. Chances I won't use them anyway. Got to do the IC socket. Unfortunately, it's going to be hard to clean this because there's nothing I can actually get in there to do it with. I'll just rely on moving a chip around in there, maybe, I don't know. Well, anyway, pick up there. Let's clean this bloody bench up. Jesus, what a mess. I'll check the chat again in a second. Right, wait till I'm checking now. Finger yoga. Oh yeah. For some reason they blocked that. I wonder why. Good chip works at 3.7 volts. Yeah. Yeah. Dave's gone as well. Just like yep. Okay. Let's get something to wipe with. Yeah, I think I put more deoxit on the bench than I did in the switches. And yeah, it's not cheap. It does go a long way though. You do get a lot of use out of it. I've had this can for a couple of years now, still going, but I do tend to use it rather sparingly because it is expensive. Over this as well, right. Okay. Now I've done that cleaning, let's see if the switch is any better for the voltage. If not, I might have to dig a bit deeper. Well, I reckon it might go bang now I've put the opposite everywhere. I should record this. Alright, let's see if this goes bang with... actually, let's turn this on. Alright. And wind it back. So, let's see if this thing goes bang. Now I've got the opposite everywhere. Get the meter turned on. And we'll check this voltage again. Switches in all places. 5 volts. Ground, ground, floating. Ground, ground, floating. Negative. Floating. Ground, ground, floating, ground, ground. Right, okay, all good. Now is it going to go bang because I've got the opposite everywhere or not? What do you reckon? It's a bit tricky to hold on to this actually. Right, turn it on. Power on. Didn't go bang. Right. Still 3.8 volts. Might go some 3.6 volt position. Let's try that one. There we go, 5 volts. Let's check it again. Make sure it's not just a fluke. Still 5 volts, excellent. So that is working, although the 3.6 is actually 3.8. Also the diode drop wasn't quite as much as I expected it to be. So yeah, cleaner switch has solved that problem. Ignore the flickering lights because my probe's opening up the contacts on the chip in the ZIF socket. Sweet. That looks fine now. That's done the job. And it does say something about these, doesn't it? Gas discharge. Let's try this pin which isn't being used. Gas discharge. Does that do anything there? 80 volts DC. Not 60 volts, again 80 volts DC on those jack plugs when it's in that position. Interesting. I should record that. So I'll just use this one here, which is not currently being connected to anything. That pin's not being used on this chip, so I've still got the ground reference though. So ground reference is that pin, and on that one I'm getting 80 volts DC. Without the side here it says 60 volts, I'm getting 80. So yeah. If I do that, does that change anything? No, I close it. So yep. So it has to be in that selection to enable these to be 60 volts. I'm not quite sure why you'd want to do that actually. I don't know. No, is that actually outputting what's on the IC pins? That's the next thing to look for. So if I stick it on ground, we get the ground there. If I stick it over there, it is. So that is, these are direct connections to the IC pins. Lovely. Okay. In fact, I can probably verify that by doing a continuity test. Let's turn the power off. Check between there and there. Yep, indeed, direct connection. I have to say I'm really liking that Fluke 289 multimeter. It suits me really well. I've got my head around it quite well. It just works the way I expect it to. It's been good. The Keysight's a bit quirky compared to the way I think, so it doesn't really suit me so well. Oh, Fred gone. What device is this? This is a Heathkit IC 7400, which is a IC tester. 60 volts for testing older VFD driver chips. Potentially, I don't actually know what that particular thing is stated as being. It says gas discharge, so I don't know. Maybe you could use it on some kind of display chips or something. I'm not sure. But basically it's a manual IC tester, so you can get those like electronic ones these days from AliExpress or whatever. You can plug your chip in, it tells you what the chip is, because it tests the pins to see if they're okay or not, like the inputs and outputs, and verifies that they're what it should be. This is basically a manual version of one of those. So the actual switches, I'll get a bit closer for you can see it slightly better. So the switches allow different options. So you go between 5 volts or ground, or 3.6 volts if you're using a 3.6 volt supply. So you can manually trigger the input. So this particular chip I've got in there right now is a 7400 or 74LS00, and this is a quad 2 input NAND gate. So with that I can actually manually test each gate to make sure they're switching correctly and not locked on or anything like that. So it just gives you more information about a chip which may not work in a modern device. You know, like if you're a modern tester may not have it in its database. Sometimes I don't have these older chips in databases, so it's always nice to have a range of different testers. So that's pretty good. I'm happy this thing works. This one's basically finished. I'll put it back together and finish this thing, and we'll work on something else. Alright, now let's put it back together. Good. It's functional. Excellent. I do have a ZIF, so I do actually have a different socket I could put on this, and it should fit in there alright. I think I'd like it more than this, actually. I mean, yeah, I have to see. It might mess up the markings though, trying to see where these markings go. I've got one here somewhere. Where is it? There's 2 bins it could be in. Let me have a quick look. Let's try this one first. Oh, it's actually unlikely to be in this one. Think about it. No, not in this bin. Excuse the feet. At least got socks on. Nope, let's drop that off there. That would be good. Oh, drop something else instead. These bins are a bit full. It's because I keep buying stuff off eBay, and AliExpress, and places like that. I'm pretty sure I've got a zip socket here somewhere. There we go. 16 pin ZIF. Got a few of them. Let's see how that fits. I mean, this has got a ZIF socket anyway. I just don't like the actual way it functions. It's a bit, I don't know, concerning. It feels like it's going to break any second, you know. So I'll stick that in there. Is that going to cover it up? Oh, it's an 18, not a 16. Is it? It is an 18. That's a 16. Here we go. Well, that could work, eh? Or not. Ah, oh, damn, it doesn't hold it. Maybe I need to do something to hold it in place, because I think that'd be nicer than the original to use. I don't know, glue it onto it or anything like that, do I? Double-sided tape? What do you reckon? Double-sided tape down there? That might work. Don't know. Maybe I'll just think about that one. I'll just keep it in mind as an option. That will work. although it is actually offsetting these lines, because the actual connections on here sit slightly above the pins. So if you're looking slightly downwards on it, that's alright. But otherwise it's out of alignment. No, I do it upside down. Actually, it's probably no better. Yeah, I'll keep that in mind. I've got options. If I can find a way which holds it down nicely without flicking off when you try and operate it, maybe I'll do that. But at the moment I'm not happy with that enough to just drop it in. Let's try and put this back in this little box. Button domes. You always keep some of these. Right. Let's put this back. Okay. Hot snot, yeah, I think that's really conducive to the quality of the product. 3D printing, yeah, it's an option. You can make like a little surround or something that sits on it. Maybe just a spacer plate which sticks onto the front panel. Alright, let's put it back together. What I should do is put this chip back in again and do like a nice photo for the thumbnail. That's what I'm looking for, thumbnail. So we've got another thing to work on just there. We'll look at that in a minute. Once we finish this one off. I'm not sure which is involved in that one actually. Find out how much has got to be done. Always put the screws in before you tighten them up. Put all the screws in before you tighten. Yeah, I think I need to do a picture of the neons running for a thumbnail just to make it look a bit more interesting rather than just a plain box sitting there. I need to heat shrink some tube over that. The tape's falling off it. I'll do it now. Get rid of it. Right. Oh, yeah, it fell off. That's exactly what I want to heat shrink some tube on. Actually amazed me, this thing came like this, right? It's a plain bar, which always falls off it when you're trying to use it. It's just, why didn't put some little bits on the end to hold it on like that? You know, that's what I needed. Got a bit of heat shrink or something on the end. This is what I'm doing. Better than the tape too. It's been bugging me for years. Oh, catch that photo, Hayes. Yeah, Thomas, it's a bit old school, definitely. But I like to get bits of quirky equipment. You know, I like to get these odd things from time to time. And this is so much as got a practical application. Sometimes there's things which, as I was saying before, you put an IC in a modern tester. The modern tester may not have it in its database. So I've got a few testers around now. I've got the Retro Chip Tester Pro, which picks up a lot of the older stuff, which is really good. I've also got a couple of modern ones as well, and other AliExpress types. And there's been chips which none of those things will pick up, but they are logic chips. So you can actually put them in this thing and actually test them with this manually to check basic functionality. Obviously, it won't pick up everything, but we'll see if it switches the gates and stuff, or switching on and off and things like that. So this is something which is going to be handy to me in future. Although, yes, it is very much old school, and you have to think about really carefully about what you're doing. But yeah, it's a nice little bit of gear. I quite like that. So yeah, I want to grab a nice thumbnail of this with the neons going, but I'll try and get the lighting right and everything. It's going to be tricky. Because I usually use a quite small aperture size on the camera in order to get a bigger depth of field to make it easier to focus. And so that makes things a bit trickier. Try and tidy up a little bit. Okay, on here. Chips are correctly round. VCC on that pin. VSS on this pin. Sorry, this pin. That's floating. Floating, yep, let's double check everything. I think we're good. Yes, okay. These don't matter. Right. So, I've been kind of grounded like that. Okay. So I'll get a nice thumbnail of this thing if I can. Little neons running. Could do a step. Oh, you look blind. I'll sort it out in a second. Second. Big up. Lighting, lighting, lighting. It's always a problem. Nearly dim enough so you can see the neons. But it's so dim it's all grainy. I've now got this set to a larger aperture to get more light. The focal distance is much more touchy. Even on that angle there, trying to get the focus across the whole thing is not easy. Right. What do you reckon that'll do? Well, the neons are still looking a bit much. This lights? Or is that really pushing it down? Try and get this so it doesn't reflect. Okay, let's try that. Not too much. The fun of a YouTuber. Come on, remote bloody work. There we go. So this remote's giving me trouble. It's being a pain in the ass. There's another one with different lighting. Right, I think I'll do. Now I need a book of truth tables. Yeah, actually that's a good point. That is true. Or false. Anyway, that's that project done. Excellent. Happy with that. I need to close the video off. I haven't done it, but so there we go. It's back together. It works. I'm super happy about that. This will be something which I use rarely, but from time to time it will come in useful. Actually, we'll need to pull this thing out and actually use it. So I'm actually really pleased that this is in a functional state. It was a pretty simple refurb, and there's basically nothing really wrong with it. It's just basic, dirt and age related stuff, No real failures, so that's good. So check out the other videos at the end. Bye. Right. Is that bit of gear done? I need to find somewhere to put it. Right, let's end up going in my other lab. I keep all my bits of test gear out there, things which I don't use very often. Something I'm going to use occasionally, I'll have it out there basically. For something maybe I don't actually see an actual circumstance when I'm going to need it within the next month, for example. I've had an email turn up. Let's have a look. Oh, wow, I've got 13 emails. Where did they come from? Ah, right, okay. Oh, someone's emailed me about review. Someone's asking questions about one of the reviews I've just done. Hold on. I'll have to read it properly later on. Study book of truth. Tables. Yes, well, no, I think I probably would need to. I forget stuff. I always have to go and refer to things. So, anyway, I'm actually going to put this IC back in its drawer before I lose it. Or stand on it or something. That hurts. Done that before. And I think this can go in the bin. I'm never going to use that for anything. Yeah, bin. Well, recycling. Right. So it's that thing. It's only 11 o'clock. Only 11 o'clock. For me. Well, they're pretty low. Yeah, I'll spin it around this way. Is that any better? When I'm across there and the other side of the room, it will be quite bad. This microphone works better close up. Because I don't have the pod mic on. I've got the I've got this LensGo thing here, which I use from time to time. I've got this as a review item. It actually works alright. It's one of those wireless remote things. But unfortunately, I can't get it to work properly on my computer. It's just, the audio is really bad on it. It's just really quiet. So I've tried hooking up, because the computer's not really got like a decent audio interface on it. I don't have a proper audio interface card on this. So using this on it isn't really possible, unfortunately. If it were possible, I'd use it. I need to do something about that, really. If I can get this case to shut again. Now I've opened it. I've ruined it. Come on, shut. Here we go. Right, shut. Back in. Yeah, if I got myself a nice audio input device for this, then I could use that when I'm doing the streams with a nice, you know, close microphone. So yeah, that's something I do want to sort out. But for the live stream stuff, this microphone's been alright. It's just have to be kind of mindful of it. That hey, when I'm far away, it gets really quiet. And I have to, because it's a directional microphone, because I've got a bit of noise behind my desk here. I've got my NAS and stuff is here. So when the NAS is doing backups and what have you and working, it gets a bit clunky and stuff. So I've got a directional microphone. So it's actually trying to not pick up the noise behind here. Otherwise, I could have it set to omnidirectional, because it does have that mode on it, which would pick up the room a lot better. It does end up being a lot louder, but then it picks up the other noise as well, which tends to be problematic. Ultimately, getting a nice lapel mic set up would be good. I just need to get an audio interface sorted out. I did buy something years ago, but it never actually worked properly. Maybe I should re-investigate this. I think I should probably do it, actually. I should just get something. Any recommendations, anyone? And no, this isn't beer. It's apple and cranberry, not beer. It's too early for beer. Right. Alright, so now I think we should look at the Fluke thing. Do you guys even know what it is? That's the next question. HDMI still running? Was it gone off? It's still going. You can still just see it there. Oh, more light. Any clues about what the Fluke is? Anyone figured out what it is? I did show it in a mailbag not long ago. I've already changed the voltage over. Yeah. 80 reference standard. So basically it generates 10 volts at 400 Hertz. And it's a reference standard. So should be pretty stable, reliable, and that sort of stuff. Sort of thing you would send away to get calibrated, and then you use this as a transfer standard kind of thing. That's really kind of what they're really meant for. I'm not sure what year this was. I don't think it has it on it, does it? No, maybe inside somewhere. But yeah, I don't think there's many capacitors and stuff in here, so I think this wants just a basic check over, really. I don't think it needs too much. hopefully. My stomach started growling. I've got some lunch here, just a little, well, breakfast really, snack bar. I was going to eat this, then we'll get onto this Fluke thing. Get the manual up. I've got two manuals. One's much better quality than the other, but it's some Arctic manuals, and they're a bit funny about copyright on the stuff they sell. Anyway, here's the manual for, which is the better quality one from Arctic Media, and yeah. If you need the manual, go and get it from them. That's all I can say. They're cheap. Relatively cheap. Yeah. Advertising them, here you go. That heavily offsets your copyright problem. Do it from them, right? Schematics. So that is basically 90% of it. It's got option cards in there as well for, like, well, this can have an option for a battery system on it, so it runs a battery as well. This doesn't have it installed. And also options for the, I closed it, was it? Oh, I can't get it back. Bookmarks? Here we go. So you've got these balls inside it, these option cards. These are different ones depending on which frequency it's set to. So this particular one here is 50 Hertz. That's 60. 400, which is what's in my one right now. That's what's in it. 1 kilohertz, 2.4 kilohertz, 5 kilohertz, 19.2 kilohertz, which is a strange one, and 100 kilohertz. So the 400 hertz one here is what I've got. So what have we got here? Polycaps, tantalum capacitors, so they're probably still fine. Don't usually fail unless they short out. So we should be good. And back on this part. It's like ceramic caps, not polarized. There's a polarized cap there, 2.2. That could be a electrolytic. Well, it could be tantalum too. Could be either one. Another one here. Some here. One there. So there's not many polarised caps in here. Obviously, your power supply will have a bunch of them. So it's there, there, here. Got a battery pack option, which this doesn't have. So we can ignore all this bit here, doesn't matter. So yeah, there's actually not a huge amount to worry about. And I think most of these capacitors are going to be tantalums, not electrolytics. And that's the battery pack option here. That's inside that box. So if I had that, then there's not much in there either, actually. So let's go to the parts list again. Main board and where's the parts list? Here we go. Oh, it does have some electrolytics in there. There we go. A couple here. C1, 2 and 3. Rest of tantalums, it looks like. So it looks like there's only 3 electrolytics left to worry about. Yeah, the rest are all tantalums. So it's looking pretty good. Not much to do. Yep, that's C2, C3, David. Yep. So what page is he on? 44. So that'd be there. Here we go. That's the ones I missed. Yep, that's the one. So there's not much there. Those 2 there and C1, which is probably in the same region somewhere. Yeah, C1 there. So that's it. The only electrolytics are in the power supply section. At least on that board. It just says main board, doesn't it? Yeah. I think it's all part of the same board. And that's the thing. So yeah, so that's it. That one board, 3 capacitors. Basically, we've got to worry about. Well, don't worry about tantalums if the power supplies are good. So my experience with tantalums, as long as they're not being run to the limits of the voltages, like they're too close to the actual voltage you're going to run at, they're probably fine. So look where they are. So there's C2, C3, and there's C1. Axial caps, no problem. Yeah, saying the tantalums generally, as long as they're not running too close to limits, like if you're running a 25 volt tantalum and 15 volt rail, that's pushing it. Or if they've been exposed to a ripple from a bad power supply, like the actual, like these ones here, if these capacitors here were going, that could mess up the tantalums right through the whole unit, potentially. So as long as there's not too much ripple, the tantalums are generally pretty good, my experience. It's usually if they've been stressed by too much ripple or running too close to the line voltage or their rail voltage. So let's pull this thing apart and look at getting to these capacitors and replacing these. It should be a pretty simple refurbishment, shouldn't it? Because it does actually work. It does function. I've already tested all that. It does actually go. So, you know, I know it's just basically a maintenance thing we're doing today. So let's go back to HDMI, which just turned off. But these tantalums in here, all they're probably wet tantalums, so they're better quality ones as well. just want to get it so you can see the front panel properly for the photo. Yeah, that kind of work. Hide it. That way, just shadows, see any problem. Right. Okay, photo done. Let's play this thing. So on the bench here I have a Fluke 5100A, which is an AC reference standard. I showed this in the mailbag not too long ago, and now it's time to do a bit of refurbishment on it. It does actually work. I've been playing around with it a little bit. I haven't used it much. I've basically confirmed it works properly. And it outputs 400 Hertz, which has got a little trimmer here to adjust the frequency here if it's slightly off frequency, so you can just trim that. And these have different options. You can get these lots of different frequencies like 50 Hertz, 60, 400, which is, this one is 1 kilohertz, 2.4, 5 kilohertz, 19.2 kilohertz, and 100 kilohertz, apparently, according to the manual. Now, because these are basically option boards, you can actually potentially make your own frequency by manipulating those values on the boards, because it actually tell you what the values are for each one. So if you actually had a 400 Hertz one like I've got here, and they wanted a 1 kilohertz one instead, because the service manual does actually tell you all the parts and what the values are, it means you can actually quite easily make your own version and modify it and change frequency if you want to. So that's really nice. Anyway, we'll get into this thing and let's go and do a bit of work on it. It does work, like I said, it's not actually broken. Just a little bit of maintenance work and a bit of refurbishment because it's an old device. I don't actually know what year this is. I'm hoping there's something inside which actually says what it is, but it's old. What year is this manual? Home. I do actually have the physical manual for this as well, actually. Paper one. 1971. So this is potentially older than me. Okay. So it's 50 years old. Not bad, is it? 50 years. So the electronic manual I've got for this thing is dated 1971. I do actually also have a physical manual which I managed to find on eBay and pick that up. So I actually have a physical manual, which is always nice. I tend to get physical manuals if I can for any bits of equipment which I'm going to keep and I tend to own for a period of time. So this thing is 50 years old. It's older than me. There we go. Look at that, beautiful gold. Gold in there. Switch here, I'm not sure what that's for. I'm sure it's in the manual. So there's actually not much in here maintenance wise that I could see from the manual as far as what we need to do to basically refurbish it. All the transistors are in sockets, that's nice. Let's take the bottom cover off as well. I did do this in the mailbag video actually, I opened it all up. These screws have got some rounding on them. The actual heads are a bit rounded, but someone's been using the wrong screwdriver on it. But you never know, I mean, this thing's 50 years old. It's been a while. And then you've got a big transformer right here. And this is the board which controls the frequency. Just here. go. You can see it says 400 Hertz right here. So I'm not sure if it's soldered in or not, or if it's just plugged in. I think it's actually plugged in. I think it's a plug-in board. Yeah, those are connectors. So those are little pins sticking off the main board, and you've got sockets on this board. So if you want to change the frequency, this is where the board you change it on. Now this is full of tantalum capacitors. Now these will be wet tantalums. These types here. These I've been surprised to see fail. They don't tend to fail, these wet tantalums. They're pretty good, in my experience. They can go, but generally they're pretty good. I tend to not think of those as something which I'd be worried about, unless there's been a main power supply failure or something like that, where you see a lot of ripple coming through this unit or high voltage or something like that. Tantalums don't like being stressed. This type less so. It's a dead tantalums which is the biggest problem. But these cylindrical type are usually pretty reliable. I don't think I've ever had to replace any of those, ever. And over here, at this end here, this is what we've got to do. So you've got these electrolytics. That's it, 3 electrolytics. That's all it's got in it, those 3. So those need replacing. Just here you can see this really nice precision resistor. This is Fluke style. A lot of Fluke gear has got this kind of resistor in it. Obviously they made them themselves or something, but they've got this format, and it's basically a wire wrapped around to form these precision resistors. So I've seen a lot of gear which is Fluke branded gear, which you've got those resistors in them. It seems to be their own style of resistor. But, yeah, beautiful piece of gear, and not much to do on that. This just fell off as I touched it. Oh, it's all split. Might have to glue that back together. Yeah. The other one's seeming alright. Just the white one. I'll have to see what I'll do something with that and fix it up. Bit of glue should be fine. That's just the ground anyway, which is just a post going to the chassis. I could probably just replace it, to be honest. Probably got something I could replace it with, but those, yeah, I might just glue it. It's not likely to be used. Is the front one split as well, is it alright? Yeah, it's got a split in the front one as well. Black one's okay. It's all been over tightened. Hate that. The other one's okay. That white one's got a bit of a split in the front as well. Just here. Yeah, just that one split, so I might need to drop a glue on that one as well. Not a big deal. And I bet that one goes to chassis too. It does. So, just chassis mount straight there. I actually covered that in the video actually. One thing, missing. Right, so I was looking at these binding posts here, these white ones. Both the white ones, the front and rear, both split. But they're just grounding points, so you actually see this go straight to the chassis. Pretty simple. So changing those isn't going to be hard at all, just because I'm bolting a new one on. But because it's only slightly split, this one's not too bad. I'm going to put some glue on it and I'll just re-glue that one. The back one's got a couple of splits in it, but I think that's also repairable. Again, I'll just glue it. And that way I'll keep it original as well. All the other ones look fine, there's no splits in the other ones, so it's good. Anyway, we'll get on to doing this. So we've got a 40 volt, 250 microfarad there, axials, and this one here, I have forgotten what that is, and I can't really see it either. I might have to look that one up, can't quite see it. But it's small, so there's a good chance I've got the right capacitor, quite likely. 250. I might have got 330. voltage. 330 at 50 volt. So I think I'm going to have to put these in. Just realised I was getting a bit low on these particular ones. That's a bit concerning. What's that one I got here? I'll have to buy some more capacitors. That'll please someone. That's 16, yeah, nowhere near it. Okay. So I'm going to have to go 330 there. And what's the other one again? C1. To find out what that is. That was page 44, wasn't it? Yes, it was. Ooh, okay. So those 250 microfarads are rated at plus 50% minus 10%. So that one's your decrease value, but they do want you to go up to maybe 330 or so would be fine. That'd actually be alright. So that's alright. And the other one's a 2 microfarad. Plus 75% minus 10%. Again, I don't want you to go lower, but it's happy to go up to 4 microfarad. Basically. 3.3. I've got some 3.3s. And that's a 50 volt cap. Oh yeah, I should rotate it around that way. There you go. Right. Yeah. So it's 50 volt, 2 microfarad. So if you go to a 3.3, 3.3, 63 volt. That will do. One of them. Okay. So I looked at the specs in the service manual for this thing. So these are 250 microfarad, as I said, plus 50%. Minus 10%, so I don't mind having a higher value, but it can't be less than that really. And this one here is a 2 microfarad, and that's got a statement of plus 25%. Sorry, it's got a statement of plus 75% or minus 10%. Again, I don't want you to go lower than 2.2 or 2 microfarad rather, but they will let you go to nearly 4. That's what they reckon, as far as the capacitor specs. So I'm actually going to increase them both slightly. So this one here says 330 microfarad, 50 volts. So that's a 50% increase, kind of, pretty much. We'll put that in, which is an improvement. And the other one I found here is a 3.3 microfarad, 63 volt. So again, that's an increase of 50% basically. Just up the regulation slightly. It does mean more inrush current with the high capacitor value, but it's probably not going to matter on these. I do actually have some 2.2 microfarad caps, so I could actually replace it with a proper 2.2. But if I'm going to change it, I might as well up spec it slightly and go to a slightly bigger one. I mean, I don't know, should I keep closer to the actual original values maybe? Maybe that'd be better. What we got here? That's a 100 volt. So yeah, no problem with values. What's this one here? That's 100 volt as well. So these are 100 volt caps. So I've got options. I could either do a 2.2, which is close to the original, or I could do a 3.3. Might have a look at the diagrams, just have a little think about it. Diagrams. Let's pull this up. So C1 is for the battery option. Which I'm not using anyway. I may actually try and retrofit this. I mean, I could probably build this circuit and retrofit a battery pack into it. I probably might do that actually in a later video. So that's coming in from J4, which is here. So that is purely power supply for this stuff. It's not doing anything else. Yeah. Stack capacitor there, C1 is not even critical. The C2 and C3 are the important ones. Right. And those are the main power rails. There's tantalums after the regulators. Yeah. Up specking those should be fine. Yeah, this is across the AC off that diode bridge. So center tap, so that's 17 volts AC coming in each side of that one. It's got two windings on that. This is the side there, and goes into there as well. Both of them do. So the battery pack's actually got two sets of supplies. Interestingly. Because that's generating plus or minus 21 volts to replace what's on here. As on supplies, that's the outputs on the battery pack. Okay. Yeah. Of course they are. So yeah, it's not that critical really. It's not even that important. Right. So I could use either one. Which one do I have most of? I have most of the 2.2s, I think. Although I could just measure it, and if it looks alright I could leave it in place. It's not critical. I haven't measured them, have I? I'll physically fit one. It will. I'm going to replace it anyway, just to have done it, I think. Just testing the circuit. That's not the right device. That's the right device. So let's test these capacitors and circuits and see what we get. So this smaller capacitor here isn't actually that critical. It goes to the battery pack option, which I don't even have installed. So it's not even used. And it looks for, look, 2 microfarad perfectly. 10 ohms though. Does a 10 ohm part matter? It's getting up there. But 2.2 microfarad, I mean if I get a... Actually I've got one here, I've got one. Put one side, I actually did get one out, planning to replace it. What do we get from this? 2 ohms, so significantly better resistance. Maybe exercising it make it work better, I don't know, but maybe. So let's check the big caps. $300, that's pretty good. 0.6 ohms, that's just measuring right. And although capacitance being increased like that, 1 ohm. Yeah, that'd probably be alright. If I get one of these new ones. I'm going to replace them anyway. They are 50 years old. There you go, 0.8 ohms. So it's actually comparable to the ones I'd want to put in. They're very similar. So, but they are old. I want to replace them anyway. So it's just done with. Don't have to worry about it. I mean, it's only 3 capacitors to do. So yeah, we'll just change them anyway, even though they test basically okay. I mean, the small one measured worse, but that's not even being used. But 3 electrolytics, let's just swap them out. What this? Oh, those ones only the bloody transformer. That's annoying. I'll have to move the transformer out of the way to get to them. Yeah. Okay. So to get to those legs, I have to take the transformer out. Thankfully, it's easy. It's almost like it's designed to come out. Now it's going to be hanging on the wires now, so I'm not sure if I can actually just swing it out of the way. Maybe I can do that. That'll still be in the way. I think it probably would be actually. Yeah. So I'm going to have to try and do something with this. Can balance it there. It's not ideal. Hate to rip all those wires out. It is all mine to put the wires all are, so if one does break off I can actually reattach it without not being concerned about where it's supposed to go. Now I've got to find out where these capacitors are. I've got to try and find them on this side of the board. Somewhere. Somewhere. Yeah. 2 big ones there. Here we go. There, 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 there. That's the big caps. The small cap, I can't tell yet. I think it's this one here. Those 2 there. So I'll put some fresh solder on and get those off there. I've got my solder sucker ready to go. My desoldering iron. And to balance that on there so it doesn't fall off. So I put some fresh solder on. Now I've got to try and get these things out without dropping the transformer. I can't need to get both sides at once. I might bounce it off the edge of the desk. Yeah, that'll work. Okay. So what I'll do is pull the capacitors out. And then I'll clean the holes out. So I'm going to pull the capacitors out, they'll clean the holes out with the desoldering gun. It's just easier that way. So I'll heat up with this. I'm holding the capacitor from the other side. And I should just be able to pull that end out. Here we go. And then I'll do the other end. Almost there. There we go. That's that one. Do the same the other one. And that's that one. Now let's desolder them. Now let's carefully roll this over and refit the new ones. And I'll check the chat. I don't think soldering off a spool is a problem. The heat doesn't really travel up it far enough. I don't think it's really a problem. I've always done it this way. So I don't think it's really a problem. I mean, if you're melting a whole spool, then yeah, sure, it's going to flow. But don't forget the flux is in a basically solid state. In a way, because it's really, you know, it's not molten yet. Oh, you'll be molten at the very end of it. So I don't think it's really a problem. So let's put this capacitor in. As usual, I've rotated it so you can see the markings. And I'll do the same on this one. Paying attention to the polarity, of course. So that's both of those in there like that. You can kind of see, can't you? And I've got to rotate it back so I can solder it in place. Well, I could solder it from the top, to be honest. I could actually do that. Let's just fold these legs around. Let's do it that way. And then that won't move. There we go. Try and do it so you can see what I'm doing. Balance transform carefully. And my hand's always going to be in the way, it's probably these sorts of things. I'm using silver solder for this. Using my good stuff. Trying to sort of get it so you can see what I'm doing at the same time as I'm soldering and seeing what I'm doing. Sometimes I actually solder from both sides. I'll get it secured and then I'll go back to the top and resolder there, because like in this case there's no track on the bottom side, so I may need to solder the top side to get a nice flow onto that joint across the actual track and the component lead. We'll see how it goes. Sometimes there's a problem. Well, here's another one which is going to be the same situation. Let's try and get so you can see. Ish. But usually put enough dwell time, it will flow through anyway and do the job. So you must have the solder disappeared, which means it's gone through to the other side. Yeah, and the same there. Right. So that's this side done. I'll clip these leads off. Of course, I still got to do the small capacitor yet. Dropped it. Carefully rotate it back. I'm trying to minimise flexing on these wires as much as I can. trying to. And it could use a bit more flowing on the top side, as I thought. So we'll do that. It is kind of flowed, but not quite as well as I'd like. So I'm going to clean the iron tip. And we'll just do a little bit here. I'll try and get in there. That's that one. And you can't see it. And this one here. See with these older boards, because they've been sitting for so long, you know, it's an old board, and there's a little bit of oxidization on the board and that sort of stuff. Even gold oxidizes, just not the same severity as other metals do, but it still does it a little bit. Get a bit of tarnishing, and so it's a bit of a freshen up with that. On this side, it'll be okay. And this one here, that's actually not too bad. I'm just going to, this one not even much. Okay, done. So I should really get a bit of flux on there. Should get a bit of IPA on there. Probably on a cotton swab and just clean up that area. If I drip it on like I normally would do, it tends to creep across the ball, and I don't want to do it in this particular situation. We'll check the chat again in a minute. Still got to do a small one here. Normally I'd use some those Kim wipes and a brush and just flood the area and just soak it up. But sometimes this is just all you need to do is a bit of a swap. You don't often see me do it this way though. The other way is usually what it ends up being. Pretty good that side. Happy with that. Still get a small one out yet. Just fold this back over again. And there. I know you can't really see much of what I'm doing right now, but I'm just cleaning a circuit board, it's not exciting. So I do have another piece of gear I could work on. But like I said, it'll be a spoiler, so I'm probably not quite ready to work on that yet. Right, where's that small one? Okay, there. Try and get hold of it if we can. It's getting too hot to hold of. This is going to be a bit awkward. Maybe I'll do it from the top side. Now I've put some fresh stuff on the bottom. That's certainly the way of doing it. Check, check. Right. Volume is so low because of where my microphone is versus everything else. I can move it slightly closer. I didn't see any green fuzz. It's got a green colouring on a tantalum, that's what it is, it's green legs. So yes, it is green, but they're dipped tantalums with colour bands to donate the values. Right, instead of having a number printed on them, they use colour bands. It's the old style of doing it. Right, so we'll get this small capacitor out now, which is potentially tricky. I've already put some fresh solder on the bottom side. I might need some more on the top side here. I think I'm going to need to, yes. Just so I can get it to wet, so I can then lift this up, just like that. And we'll do the same for the other side. I think I've still got that transformer floating around, I've got to be careful about that. Come on. No, solder on this one as well. There we go. Separate out. Okay. Somehow I solder bobbed my solder. Solder bobbed onto it. That's annoying. Anyway. Just clean these holes out. Go from the top side this time. No, it didn't clear. There it has. Now, as the part's not in the way, I'm going to give it a clean. Maybe a new swab. Okay, so it's cleaned up. If you can see that. positive side is marked as this end, and it was actually that way around. You can't always rely on the markings on the board. Right, so that's got a positive sign there. There's been equipment which I've worked on which is actually wrong. So never assume that the marking is correct. Always try and remember it. For instance, there's a piece of gear which I've worked on recently, which is I've recorded a video on. Haven't released any video on it yet. I've got a 5-part series, and that actually shows that issue. It's not rotated quite enough. The particular part was installed backwards from the factory because the markings on the board were backwards. Anyway, so that's that. Let's solder it in place from the top, and I'll touch up from the bottom once I've flipped it over, rather than going backwards and forwards. And I probably can't see what I'm doing. Come on. It's not easy to try and do this to video at the same time. Right. Let's clean up in a minute. I'll do that after I've flipped it over again and done the bottom side. If the bottom side needs doing, that looks fine. I don't have to do anything here at all. It flowed through nicely. So let's cut those off. Clean up both sides, and then we can try it out again. That's not working too well. Need a cotton swab. Right, so we'll transform back in. So I'm just refitting the transformer, then I'll flip it back over, clean the top side up. Come on, in you go. There we go. Okay. That's in place. Double check the wires, nothing's broken off, hopefully. Yeah, they all look alright. Cool. So let's clean up the top side. Okay, that's just about done. This should work fine. Better anyway. Clean up a bit, then I'll put it back together and check the chat. Yeah, those tweezers I've got, I've had them for a long time. I've actually been hoping to try and find some more like it. I've had those for 30 years, probably. I've had them for as long as I can remember, basically. Alright, let's rebuild this. Which way does that go? Does it matter? Maybe? I think that was at the back anyway, so yes, that goes in like that. You know, by putting it back together now, I'm jinxing it, don't you? Realise that's how it works. And I put the feet on the top. So I sort of heard something that I'm currently home alone. My wife is out visiting friends and stepson's gone off. Anyway, yeah, hold on. When you say something, people should have said, hey, put your arse down. Anyway. Again, why is there no adjustments on the bottom? Do it again. And that's the back that way. Completely wrong. And the sides. Yep, that's it. So yeah, I might actually retrofit a battery to this, I'm not sure. I probably won't actually need the circuitry it's got, because it's got a complex circuitry in there to do a battery charge circuit and stuff like that in there, isn't it? So I could probably simplify that greatly and actually rebuild that circuit as is, but put a lithium-ion battery setup in there instead. I don't think I want to do calibration stuff. I don't want to mess with that really. I'd rather keep it as is and see what happens. It's not hard to open it back up again anyway. I might have to go through the calibration manual at some point and just maybe do a bit of verification more than anything else. Make sure it's not completely out of whack. What's that? Yeah, we'll use this. Right, let's try this thing out and see if it still works. Power onto the unit. Power switch on. Set to AC volts. Let's just shove these in the front. Like I've only just turned it on, so it's got to warm up and everything. Same for this multimeter here. It's all only just been turned on. So there we go. This will settle down a little bit once it warms up. But it's working. What we can actually do now is check frequency. and it's doing 400.24 hertz. And yeah, it still works. It worked before. This is just purely maintenance really I've done, so I don't know if this is wrong or whether this is wrong. I don't actually know which one's wrong, to be honest. Just another test. Yes, I should probably put the right leads on this and do this all correctly, but you know, yeah. It's just ballpark stuff what I'm doing. And I think I might need to make this so this will hang off the edge so it locks it in place. Volts AC, right. Let's probe into here with this, compare it with the Fluke. Which one do you believe? The Fluke or the Keysight? Which one do you think is likely to be more accurate? The Fluke or the Keysight? Let's do second frequency. Let's do frequency on it as well, shall we? Yeah. Let's do frequency. See what this thinks of it. 400.25 hertz. So at least the frequencies match. Voltages don't. Which one's right? We shall never know. I think the Keysight was more accurate from memory. Oh, sorry, the Fluke was more accurate. I think the Keysight was slightly off. Let's plug these leads into my Siglent and see what the Siglent thinks of it. Although I've only just turned it on. Siglent currently says 9.994, but again, if I just turned it on, it's got to warm up. A bit more critical on that one. You going to Keysight? Oh, you might be wrong. Kaboom, yes. I'm live, yes, I am. Conundrum. Yes, so my Siglent currently says 9.994 still, and it's just trying to see if it's creeping upwards or not. Could be. I'll do some other multimeters to test on. Have the Bryman 869. Plug the leads into this. Of course, they both fell out. Again, I just turned it on, so accuracy, I don't know. Maybe it does need a bit more time, but it should be close enough still. Gives an idea. 400.26 hertz. So 10 volts, nice. Selections, here we go, that's what I want. So the 869 is actually reading higher. Oh, it's creating doubt. Got 2 read low, 2 read high. Okay, let's keep going. Okay, we had the 786. $10 exactly. Well, one count high. This one's actually pretty good, this meter. Well, that's what Fluke says somewhere. Hold on. Where are the Flukes? Where are the Flukes? Okay, got the 87. Let's get this out. The reason I don't use this one on camera is because it's harder to see the screen. See, it's much harder to see it. Okay, Fluke 87. 10.01. Yeah. Yeah, I don't have the high res mode turned on this one. Anyway. Not that helpful, that one, was it? Not enough precision. Okay, we also have the Fluke 107. Put the leads in the right holes because, you know, it really matters on AC. Volts AC. Untangle the leads because it always gets tangled up. $1.98. Oh. Maybe we'll never know. What else we got? Got the BM235, which was my go-to meter on the bench here for quite some time because it's a good little meter. Really like this little meter. It's got a good display on it, that sort of stuff. Pretty accurate, I say, as we get 9.1 volts out of it. Okay, maybe not so accurate on that one. Maybe it's got one VFD. There we go. 10.01. That's the same as what the other Fluke gave us, wasn't it? That's what the 87 said. Yeah, the multimeters I can use. Actually, yes, there is. I've got the Fluke 117 in the car, so I can't show you that one. Oh, this was looking really bad. What have I been doing to this thing? Right. Volts AC. Hey, it still works. This is my original kick around meter. This one I used for years. As you can see, Was this one, I think, but 10.07. Same thing the Keysight said, isn't it? I've got any more meters? Of course I do. What about this one? Has this got any power? No, no batteries in that one. No, I think I do want it. I think you get the idea. I've got way too many multimeters and stuff, and none of them agree. Right. I need to wrap up this video. But the 289 low Z, yeah, I could do that. The frequency I'm not worried about. It's adjustable. There's a little trimmer on the front panel there which changes by up and down 1%, so I can easily just tweak that. It's not a problem. That's why it's on the front panel. What was it like on a scope? Well, you could do that actually. Hook up to a scope. I have differential probes, but it's only 10 volts, so yeah. And it's a floating thing, so I believe I can hook it up just fine. I don't think I need to worry about differential expense. It's only low voltage, low current. Let's get back on here again. What are we trying to do? Oh, 289. That's not a multimeter. It's the other multimeter. Anyway, right. I've got the point on that one. Okay, low Z. Give it on camera so you can see it. How's that? As you can see, the resolution is not great. Not enough resolution. So, check it on a scope, you reckon? Cable. I could do it on a computer screen and like do a feed from the scope from the web browser, and I could do all that stuff, but I'll just do this because it'll be good enough for what we're doing. So what we got? 1 volt division. That's not good. Yeah. 5 volts of division. AC coupling, won't we? We want AC coupling. So there, 48 at once. I was playing with this yesterday, I was using it on something else, so I need to make sure I've got it all set up again. Full bandwidth. AC coupling. Oh, not ground. AC coupling. Okay. 1 meg ohm input. Shove it in. And center it. Is there somewhere? Oh, that one there. Looks nice. Nothing wrong with that, is there? Should record the video on this, I suppose. So I'll just chuck the output on a scope here just to see what the output looks like. It looks absolutely fine. There's no signs of any problems on that waveform. There's no signs of glitching or disturbance. It looks fine. Highway frequency counter says 400.23 to 26 around there. It's not wonderful. But yeah, that's looking alright. Happy with that. Looks good. Measurement stuff. Hold on. Measure. Come on, where is it? Am I about to do it through the menu? Channel config. Where is it? That's not one to do. Let's get the mouse. It's a bit awkward trying to do it like this. It's a bit awkward where I'm sitting. Right. Channel 1. That's what I'm looking for. Channel 1. And you can see the Siglent scope is reading slightly high. Let's give the frequency a tweak, shall we? I could do this in a multimeter instead, but we'll just do here. That's the wrong way. It's hovering around the right one now. That's around 400. So there you go. It's a bit of a closer view. I've changed the frequency a little bit, just adjusted it a little bit on the front panel of the unit, which is why it's got adjustment on the front, because it's one of those things you need to tweak from time to time, because it's just capacitive tuned, and ambient temperature affects it somewhat. So that's now reading around the right value now, around 400. It's looking pretty good there now. And yeah, it's interesting the way the scope is saying it's 10.1 volts. Well, no, it definitely isn't that. Right. Those probe masters were given to me by Joey, who I don't think's here. He sent them to me as a bit of a gift package thing he sent me. And yeah, they're alright. I don't use them that often. I've got them on one of the multimeters. Basically, I'll try and keep a set of leads on each multimeter, so depending on which multimeter I'm using, that's the one that's got those leads on it. So I've basically chosen the leads to be what suits that meter, what I'm going to use that meter for. But the ProMaster ones, that's alright. They've got the hot points on them. Oh, those the sprung ones? I think it was the sprung points, weren't they? Am I thinking the other ones? Yeah, these are sprung points. So, it takes me getting used to. You have to be careful not to slip off stuff, but I think the spring actually helps slightly with that. Anyway, I think we can... FFT, you wanted FFT, didn't you? Right, mouse. Use the mouse, it's easier. Menu. FFT function, here we go. Now, I've rarely used this. Let's see if I can remember how to bloody configure it. It's 1 megahertz span. What's that going to do? No. 2 meg span. Start at 0. Okay, nothing really up there. Actually to end of, let's do 1 megahertz again. It was doing 1.1. So doing 400 hertz, so we can drop this down by quite a bit. Let's do 1 kilohertz. You see the vertical here is going off the scale. Vertical scaling. Units, volts RMS. There we go. So yeah, that's just looking fine there really. Let's bring it in a bit closer. Actually, no, I want to do this way, don't I? Done this wrong. So 600 here, 600k, and start of say 300k. Oh, 300 hertz, 300k. What am I doing? I want hertz. 300 hertz. 600 hertz. Wish I really should get this right. Here we go. So that's an interesting little profile there. Is there anything else we can do in here? No, I think that's okay. This is thing is 405. Interesting. I don't really know how to use this that much. I haven't used it much at all. So yeah. Actually turn it off again. But anyway, it's no real harmonic stuff showing up there. If we go back up to say 2 kilohertz. There's like nothing. So it looks fine. I suppose I could go back up to say you're at 1.3, or thinking you were thinking of kilohertz when you were saying, don't you? It's 400 hertz. This thing's running at 400 kilohertz. Oh, we'll do there. 1.3 meg. Here we go. And start at, let's do 200. I'll put it back to 0. Should be over here somewhere, but I don't want to see it. I've broken it now. I've got maximum number of points. Should I do full screen? That one then. That's fine. So that should be right. Why aren't I seeing it here now? Was it just because it's there? Fine, let's do 500k instead then. Why aren't I seeing it now? 10k, there we go. It's just, yeah, it's just sitting right up here on that edge. So, yeah, you couldn't really see it. Anyway, yeah, there's nothing there. It's just, that's it. It looks absolutely fine. Config. Let's go back to split. Okay. And there's an FFT version of it. I've got it going quite a long way up in frequency here. Actually, just reduce this a bit. And let's go down to say 1k. And here we are. There's a 400 hertz here. And basically it's flat each side of that. There's no signs of any problems with noise coming out or anything like that. So it looks good. Off. Right. To do the ending of the video. I'm getting a bit crowded here with bits of multimedia everywhere. What's missing in that space? Oh, that's the installation resistance test. Put that way. Looking at a blank screen, it must be thrilling. Whilst you can hear me packing things in a box. So let's put this over here. I really need to reorganise my drawers here. It's just getting ridiculously messy in here. Okay. Let's close this video off. This something I'll do a little video on as well. This resistor. I blew this up. I've already pulled it apart to see what's in it. I thought I'd do a video on it. Little short one. Alright. There we go, that's that fixed. Well, wasn't really fixed, was it? It was a refurbish. It's working fine, I'm happy with that. I've still got to do the gluing on these knobs. I'm not going to bore you with that though. You can imagine me gluing knobs, can't you? So yeah, check out the videos at the end. And if you want to give me a thanks down the bottom there, a little donation, you can do that. Or you can become a Patreon, help support the channel, and help me to buy things like this to work on. And to add to my inventory of test gear to use as references and whatever else I'm going to do. Try and make interesting videos. Alright, thanks for watching. Slow. Stop recording. There we go. Alright. Bloody remote. I don't know what's going on with that. I really am thinking it's the camera. I've tried different remotes and all of them are playing up. I shall come back to the computer in a second. Just switching over here. Alright. Okay, back. And go to this one. Turn it off. The fixed variation stuff. Well, 400 Hertz is a good frequency for testing lots of gear actually. It's a good reference frequency for testing multimeters and stuff like that, because 400 Hertz is often within the frequency range of multimeters. 1 kilohertz is sometimes at the very top end of the frequency, and 50 Hertz, 60 Hertz maybe, are obviously well within range, but it tends to be a bit noisier and you get affected a lot more by ambient noise. Oh, Peter's gone to level 2 membership. Well done. Doing much better. Yeah, the 400 Hertz is obviously aviation frequency pretty much. I use 400 Hertz AC, but I don't know a lot about it because that's basically it, really. But yeah, 400 Hertz is a good frequency for testing multimeter stuff like that, because they basically should all cover it. Now, if 1 kilohertz is the maximum they can cover, 400 Hertz should be a reasonable frequency for it to be able to measure and have, you know, decent measurement accuracy on. But then, as you saw with those other multimeters I was checking before, every single one of them was different. Yeah, but if you get a low frequency like 50 Hertz, then you get, you know, or even a 100 Hertz, that's a pretty much guaranteed accuracy to, you know, all the meters will read that without any trouble. So, yeah. Anyway, well, that's done. That's a simple little refurbish work. That can go on my stack here behind me. This is my calibration stack. It normally sits right on top of there, like there somewhere. But you may notice my stack's getting higher and higher. I've got a new piece of gear here, sitting right there, which I've got, say, 5 videos recorded for, and I think I might publish the first one this week, although I haven't edited them yet. Still to do editing. Yeah, so I think I'll do the first one this week. Yeah, on Friday that'll come out. Thursday for most of you guys, Friday for me. So yeah, that'll be the start of that. That'll be going for, I'll probably do 1 video a week on that. Just did a Friday video on those, and that should be enough. Tower of Cal, yeah. Advantest, yes. Advantest, not Tech. The 8.5 digit multimeter, which I showed in the mailbag last week, was it? Was it this week? I don't bloody remember. Mailbag recently. So yeah, that's what that is. And it works, kind of. I've had to do some work on it. I've managed to get the display better, that sort of stuff. Did some corrections for fancy errors. Used references to calibrate it. I've got my, because it only needs a 10 volt and a 10k reference to the calibration. So if you know exactly what your 10 volt reference is, exactly what your 10k reference is, you can tell it what they are. It does an automatic cal based on those two. That's it, called an artifact calibration. Yeah, it doesn't do AC. It's the T model, so it does DC and AC. DC and resistance only, and DC current to a small level. Well, what's worrying me about my tower of calibration stuff is that it's sitting on top of a filing cabinet, which is a wooden filing cabinet, and it's all sitting on that top board. So I've got the very bottom piece of gear here is my Datron calibrator. That thing weighs, I think it's about 32 kilos or something like that. But it's got the wings on the front. So the wings on the front are actually resting on the side rails of that filing cabinet. But the back of it is sitting just on the wood. So all that weight, basically the back half of that, is all on the wood, on the top. And if it breaks out the screws, which it could happen, then the whole lot's just going to collapse into the drawers. So that's what's worrying me about all this. I'd actually buy something to replace this. This is the transconductance amplifier, which I did a repair on. I think I did it in a live stream as well, which has that 10 amp current reference, basically, up to 10 amps on it, 12 amps most, I think it was. But I did find a Datron version of the same thing, which is smaller and lighter. And I did buy one. Never arrived, hasn't turned up. Frustratingly, the guy had about 4 of them or 5 of them or something like that, different ones, and bought one. It wasn't cheap; it was like $300, and yeah, it never turned up. So got money back on that one, thankfully. But it's disappointing because I was actually looking forward to that. That would have been a good piece of gear because it's with a Datron here, and it looks like it's the same chassis as the 106.2s, 108.2s, 107.1, like these multimeters here, which you can barely see in shot. It looks like it's the same chassis, and I've got some 106.2s out in the lab, which I'm trying to sell. And I think if I change the casings over, the front panel will be different still, but obviously, but the casing, that'd actually help it to match this gear. It'd be a bit more matchy, you know. The casing will be the same, so the front wings and stuff will be the same, but the front panel is white or cream, whatever it is. But it's the same size as one of these, which would have been nice. It would have been, a bit more matching. It would have been nicer. And in theory, it's also controllable by my calibrator, being a Datron unit. But the calibrator needed a newer firmware than one it's got, so I don't think it would have actually worked. It did specify a firmware version to use when linking the two together, so I don't actually know if I could even upgrade the firmware and the calibrator to make that work. If I could have done, I would have done it, I think. But as it's not arrived, it's academic. But yeah, I'm hoping it's just gone missing and been delayed, and it eventually turns up. I had something else I bought once. Got a Dataman EEPROM programmer. Sit out there on the shelf, and that was 5 months. It took 5 months, and it arrived. It just turned up 5 months. That's off eBay, you know. He got sent pretty quickly, but it just disappeared. And then a few months after that, about 3 months after I claimed it, I think, then it turned up. So who knows? Maybe it happened with the other thing too, but you know, yeah. Anyway, so that's all right. We've done a couple of bits of gear today. Killed a bit of time. I'm annoyed that my tablet won't bloody sync up with the computer. I don't know why it's being like that. I need to figure that out. If I don't drop it or something first. Yeah, anyway. Well, I reckon I should go have some lunch and have another cup of coffee and stuff. And let you guys all go and go about your day or go to bed or whatever you're doing. So thanks everyone for dropping by. Hope you found it interesting. And I'll catch you another time. There may or may not be another live stream next weekend. I don't know. We'll see. It depends how I go. I've got nothing planned. I've got, I think, 3 weekends free now until I have to work a weekend again. So live streams could be possible. Don't forget to give us a thumbs up before we go as well. And yeah, so we might see if I can do something else as well later on. Maybe have a live stream. Depends what else I've got to work on, what to think around with. I do have something here to work on, but it's quite involved. But then it probably could do a live stream. I'll have to research it a bit and just see what I've got as far as parts and things like that, and see what I can actually do. Speed the process up a little bit, but it's got lots of bits which we need replacing. But that shouldn't be that hard, I don't think. I don't even know if it works. Haven't powered up yet. No idea. So it could be an interesting one. Okay, I'll catch you later. Thanks a lot.